in the opposite direction.
So would you say the upside down?
Sure.
As in, like, can't they fall off? Look, if it's round, the people at the top are okay, but the people at the side are okay, but the people that are at the bottom, they're like this. They can just fall.
Yeah. The gravity pulls them towards the center. So if they're on the bottom, they're still being pulled towards the center by gravity.
But why would you say round? Why not any other shape? Let's
Well,
say,
because it's a globe, like a basketball shape or a football shape, not American football shape, European football shape.
that's fine. Thanks for that. I'll come later on if I get more info, like, because I'm still like studying.
For sure. All right, I appreciate you coming up.
That's fine, thank you.
All right, let's go on to the next person. Only send a guest request if you are a flat earther, y'all. We are just looking for some flat earthers to debate, y'all. Yo, what's up? How old are you?
31.
For sure. Do you think the Earth is flat?
100% believe it's flat.
Why?
We just see too far.
What do you mean?
We see too far. Like, just look at those. That photo just recently taken. It was, I believe it's 700 miles away, and you can see the peaks of Mount Blanc from England.
Oh, we were talking about the Swiss Alps one. Yep, those aren't the peaks of any mountains. Those are clouds.
Clouds.
They're
not
clouds.
What
and it's been so we can look at the exact same image, or we can look at the exact same photographer set, when they take multiple pictures from a certain location. Mm-hmm. And you can tell that from that exact same location, you can, from the same photographs from the same location at different angles, you can figure out where they are. And then you can take pictures from that same location on a clear day, and those peaks are no longer there. And this has been done. I've seen photographs from the same location on a clear day, and there are no peaks off in the distance.
Well, then how do you explain that observation of, I believe someone saw the mountains from Crete while they were on the beach in Israel?
They weren't the mountains from Crete. They were looking in the wrong direction for them to be the mountains from Crete. This has also been debunked. In particular, you can check out the direction of... So in that same picture, you can see an oil rig. The peaks are on the wrong side of the oil rig. If it's actually the mountains from Crete. Yes, they are.
Interesting.
It's just it's just like fake. Well, I mean, it's a real photo, but it's not of what you think it is.
What about the Chicago skyline being hidden? Like, you can,
Why should it be hidden?
See it.
Yeah, you can. The buildings are quite tall.
But at a distance of 75 miles, shouldn't it be hidden by like 60 miles of curvature?
No.
I don't know. It's just these observations, and then, like, coupled with Werner von Braun mentioning the firmament on his tombstone. And
well, he doesn't mention the firmament on his tombstone. Also, the person who wrote it on his tombstone wasn't him, because he was dead.
It's a good argument. But I believe it was Psalms 19 something.
Right. And was Werner von Braun using the King James version, or was he using the standard German version?
Oh, I couldn't speak for that.
Well, you could. He was a German man. You can go look at the German translation of that psalm, and then you can translate it to English, and it translates to something like, the fortress of the heavens are, strong, or whatever it is, but it doesn't say firmament anywhere. The German word that is the German version of that psalm doesn't include the German word for firmament.
Interesting. And why would you say, like, the Earth tilts at a 66.6 degree axis?
Tilts at a 23.5 degree axis, or 23.5 degree angle. I'm sorry.
I thought it was 23.4, and if we
it's 23.5.
Take it out of 90, it equals 66.6.
Well, it's 23.5. So.
One second, I'm referencing my script here. I mean, not my script, my advanced
Bamble
images.
fix. Are you trolling?
I'm getting troll vibes.
No.
Yeah,
Bamble
he's trolling.
fix.
He's definitely trolling. He's
Funny
definitely
story.
trolling.
There's a guy who used to hang around a lot, named Level something or other, who literally would claim to eat my...
I'm a professor at UCLA. I can debunk this theory of the Earth being flat. The Earth is indeed flat, and I got 3 good reasons behind why the Earth is flat. The Earth is flat because your mother sat on it and turned it into a fucking pancake, and she got her big.
The destruction. No. So there's this guy who every time I would see him, he said, "I'm going to eat your script for breakfast." Like, and then at one point,
Can we get
he
a
claimed that he
W
was
Mia
going
in the
to eat my
chat? Can we get a
breakfast.
W Mia? Yo, what's up? How old are you?
I'm 25.
Yeah, for sure. Do you think that the Earth is flat?
Yes, I do. And greetings to everyone. Hope everyone's having a good day wherever you are. I'm an open
Why's that?
flat earther. I haven't been one for a long time, so I do enjoy these lives where I can get information. So I just have some questions, if that's okay, like based on why you guys believe it's a globe, if that's all right.
Absolutely.
So I just wanted to understand, I had a couple of questions actually yesterday for someone I went live with and they couldn't answer it, but maybe you guys can. My first question is, do you also believe that we are traveling through space at millions of miles per hour every day?
Relative to what?
So because we apparently we're moving, like we're orbiting the sun, but the sun's moving, like we're kind of like chasing the sun type thing. Like, do you believe?
Well, yeah,
in
but
that
like
as well?
relative to what? Like,
What do you mean?
Like if you
Go ahead.
So like if you're on a train,
Yeah.
and you throw a baseball to your friend,
Yeah.
maybe relative to you, the baseball is moving like 20 miles an hour or something like that.
Yeah.
But
I'm
relative
just saying-
to somebody
I'm
on the
just-
ground, it might be moving at 80 miles an hour. So, speeds.
So if we, yeah, go ahead.
you have to measure speeds relative to something.
Okay, I'm
So
just
that's why
saying,
I'm asking.
like I said, I just have these questions. You guys could teach me something as well. I'm saying from, let's say our point of view is from space. Would we physically see Earth moving like millions of miles per hour?
Space isn't like a thing, so I don't know how fast we're talking about
Okay,
here.
so
like if we're talking relative to the
based on what I searched on Google, apparently, I'm saying apparently because we can't agree here, but I'm willing to move on, that we are chasing the sun millions of miles a day through space.
So relative
But
to the center of the galaxy, we're moving something like, I think it's like 500,000 miles per hour.
Okay, yeah,
Relative
yeah.
to the sun, we're moving like 35,000 miles per hour.
Okay,
So, or
My-
maybe it's 35 miles per second. I'd have to double check.
My-
But
my-
the point is it depends on what you're measuring relative to.
Okay. My question is based off that. It's so if we are doing that, how are we? Because we obviously agree that we are not the biggest planet in space,
Yeah, Jupiter's
and
very
we are
big.
not. Yeah. So disregarding the ones that are also orbiting the same sun as us, how comes for billions of years that we've been chasing the sun through space, we ourselves haven't collided with anything that's bigger than us in space? Like, that's a genuine question. I'm not trolling. I actually asked someone this yesterday. They wasn't able to answer. Why is it that we haven't hit?
There's
Yeah, go
basically
ahead.
two reasons. The first is that, so Earth and the sun, the solar system in general, is orbiting the center of the galaxy in like
Yeah.
one big circle. It takes a really long time to go around, but so is everything else. Everything else in our vicinity is also orbiting the center of the galaxy. So it's
Okay.
not like we're all moving in random directions. We're all moving in roughly the same direction. But more than that, because that's not the only factor at play here, space is really, really
Yeah,
big.
yeah.
It's so big. And so like the distance from the Earth to the sun is
Yeah.
peanuts compared to the distance from Earth to even the nearest star.
Okay.
So
Well, I read
even if we
somewhere-
were just
so
moving
go
around,
ahead, go ahead. No, go ahead. It's fine.
even if we were just moving around randomly,
Yeah.
even if if you took the Andromeda galaxy, which is the nearest galaxy, it's very, very big, and you collided it with the Milky Way galaxy, the probability that any two stars would actually collide is so close to zero that because this will happen in about 4 billion years or so, we expect that no two stars will collide with one another. That's how much space there is between stars.
Okay. And also there is obviously I'm a flat earther, so I disagree, but I respect your point of view, if that makes sense. I won't argue against it. I respect it. I just have some questions. Like I said, my second question was, don't quote me on this, I'm really bad with names, but there's a stone, I think it's called a Georgia stone, if I'm not mistaken.
Georgia Guidestones, yep.
Yeah, and it has a hole in the middle of it, and we are still able to this day to look through the hole and see, there's a star that starts with the name of P. I can't remember it.
You're talking about Polaris. Yep.
Yes. How are we, a genuine question again, how are we able to still see that if we are technically moving at 500,000
Well, we're
miles
not able
per
to still see it. We're not able to still see it because the Georgia Guidestones,
Go ahead.
They don't exist anymore. The Georgia Guidestones don't exist anymore. They were broken like a few years ago. The Georgia Guidestones were built in the 1980s.
Yeah.
So they were only standing for like 40 years.
Okay, 40 years, but this is what I don't understand. If we're moving so fast through space, why could we, in those 40 years, why was we still able to see it if we're moving? Surely, I don't know if this is a light thing or maybe we think we can see it and we can't. I'm not sure, but why was we able to see it for those 40 years then?
It's because space
is so big that we can see a star from 40 years ago still in that same position.
Yeah.
Come on.
So hold on. So just like, you know how when you're driving on a highway or driving fast, the trees nearby, they look like they move really, really fast. But if you see a plane off in the distance, it looks like it's moving really, really slowly. The further away something is from us, the slower it appears to be moving. Whether you're moving or whether it's moving, regardless, if the distance is small, the slower it appears to move. So the distance between us and the nearest star, not Polaris, Polaris is 100 times further away than the nearest star. The distance between us and the nearest star is like 13 quadrillion miles. And so even if we're moving at like, 35 miles per second or whatever, that's nothing compared to how far away Polaris is. Polaris is like, I don't know, like a 1 quintillion miles away. Like it's so unfathomably far that like a plane off in the distance, you wouldn't see it move at all, even over the course of hundreds or thousands of years. In fact, Polaris has been in roughly the same spot for at least 2,000 years.
And we're just able to see it based on how fast or slow it actually is.
Well, moving. So it's moving, we're moving relative to it quite quickly.
Yeah.
But it's so far away that like the position, so like when we talk about where something is, it's like the angle that it makes, right? Like the angle that it makes.
So are you saying that we're moving closer to it? That's why we're able to see it?
No. It's just that even if we were moving like, perpendicular to it or whatever, it's so far away that the angle that we look at to find that star is basically unchanged from year to year.
Is that the same? This actually leads into my last question perfectly. Is that the same for the Orion's belt? Why we still see that?
Yes. Yeah, it's the same for every star in the night sky. That's why the stars look the same or the constellations look the same year over year. Now they do change slowly. So the constellations that we see were different than the constellations that Egyptians saw 4,000 years ago. Slightly different. Not like completely different, but slightly different. But over the course of a human lifetime, they don't move enough for you to notice a difference.
Okay. I think that was all my questions. Like I said, I had some respectful questions. I respect you saying that it's a globe. I'm sure you can respect other people who say it's a flat earth. Obviously, I haven't been moved by anything you've said to make me say, no, it's a globe. But you have answered some questions I had for a very, very long time. So I respect you both, and I hope you both have a nice day.
You as well.
Thank you.
For sure. All right, let's go on to the next person. Everyone, only do send a guest request if you disagree. We are just looking for some debates, everyone. Please only send a guest request if you believe that the earth is flat. Everyone, let's go on to the next individual quick.
We can go scripture by scriptures knowing that the earth is flat.
Okay, but like scholars are going to disagree with you, and they've studied this for decades. How do you know that you're correct?
It cannot disagree when it's in black and white.
What do you mean? What do you mean? They literally. So why don't they hold the same position as you?
Tell me, in those creatures, what changed for them in their mind, thinking that it cannot be flat or it cannot be round.
Say that one more time. Sorry.
In the scriptures, it doesn't change. It just, if you translate it to another language, it's still meaning the same thing in a different language. Maybe they have a different way to say it, but still meaning the same thing. So in the scriptures, in all the scriptures, starting from Genesis, all the way down, it will show you proof that when God created the earth, and this was God created the earth, not the sun was first and then the stars, and then we created from galaxies and all this stuff millions of years ago. What proof people have of that? That's a myth. It's like
We
saying
have lots of proof. Like
Bro,
so much proof.
everything by what show when you guys are telling people prove me that the earth is flat, you guys are not telling nothing to prove that the earth is round besides all you guys talking and what we see in TV. It's all
I mean, I can
government.
give you evidence if you want.
It's like we can give you evidence, but you guys not.
I just want to
gonna-
ask you one question, Nelson. Can you
Yeah.
explain to me why the sun sets?
It doesn't sunset. It doesn't.
It doesn't?
No.
The
It's
sun
no
doesn't
way-
set.
It does. It's just move far away, and you can see. It's like seeing a bunch of light poles, right? And you got a flat lane like a highway, and it's all straight. When the pole that is right next to you is very tall, but the pole 5 miles away is very little. So
Nelson,
you can see
Nelson,
that
great.
the pole is very tall next to you, but the pole right 5 miles away, you look even with a telescope, and you look like, wow, that is 5 miles away. But you can see like
Yeah,
super small.
Nelson. So like, when we go out and I don't know where you live. Maybe you live by
Minnesota.
the ocean. Minnesota. Okay.
Yep.
Well, have you ever seen the sunset like over a body of water?
Yes.
Okay, so you know how like it looks like this, and
Yep.
then here's the water, and then it does this,
Yes.
or
It
rather
doesn't
like
do
this.
that. It doesn't do that. That's a myth. It doesn't
We've all
do
seen
that.
it.
No,
I can
you
show
see
you
it with your
pictures.
eyes,
Should,
but
should I?
make it- put a
should-
telescope
wait, should I show you
in that same
pictures?
sun, put a telescope in the same sun, and look at that.
Should I show you pictures?
Yeah, we can see pictures of me, and you can.
Do you want me
I
to
can
show you
see-
pictures of the sunset, of videos of the
It's not a
sunset?
It's how the vision of your telescope can see.
Look, bro. I'm just talking about how the sun appears to do this, right? That's
But
just
it
what
doesn't.
happens when we see the sun, right? When we look at it, we've all seen it.
Yeah, what you can see, that's the problem. We think that's the problem is that we think that because we cannot see farther than that is
Right.
doing
Okay,
that.
I understand that that's what you think, right? So my question is just, let's say, do you believe that the equator exists? That there is a place that we call the equator, like Ecuador or Equatorial Guinea? Do you believe that those places exist?
Yeah, words that people put in. Yeah, it's okay.
Okay, so let's say that it is September 21st. You are in Ecuador. The sun rises in the east and sets in the west. Ecuador is actually on the ocean. There's a coast. So let's say you're in Ecuador, on the equator itself, looking at the ocean.
Okay.
How long does it take for the sun to appear to go from here to here? On September 21st in Ecuador.
I mean, I'm in my computer right now, so I can.
No, don't Google it.
Oh, why not?
Because in my model, I can predict
but you have
how long
your
it
model.
takes.
Okay,
In
you
your
can-
model, can your model tell me how long it'll take for it to go from here to here?
No,
Alexandra, thank you for the $1, and Adam, thank you so much for the 10 on Cash App. I appreciate it.
So
no.
if we're doing science properly, it seems like what we should do is we should use the model that makes the most accurate predictions about things
But
that we
you just
observe.
said it's prediction.
Yeah. So my model would predict that it takes almost exactly 2 minutes for the sun to go from here, just before it appears to touch the horizon, to here, just before it appears to completely disappear behind the horizon. That's what my model would predict. The question is, how does your model predict that? Does your model predict that same thing?
Remember, we all following the model that we was teach to follow.
No, I'm saying that my model accurately predicts what we observe happening in nature. Does your model?
Problem. Because if
That's how we
we
do
go back
science.
to the Mayas and we go back to the Indians and the Taínos, when they was predicting sun and moon and time, they didn't have no model, no computer or nothing like that.
I'm not talking about computer models. I'm just talking about like a conception of what the world is like in our heads. We can use that and use some mathematics to figure out how long it should take for the Earth or for the sun to go below the horizon. The question is, in your model, can you do the same thing? Can your model, using the flat Earth idea and the sun getting further away, can that tell you how long it'll take for the sun to go below the horizon? Or for the sun to appear to go below the horizon, rather?
No, because we don't go by that.
So then your model is worse than mine.
No, the problem is that you guys are using a model of globe. And that
A model is just a mental conception of the way the world works. That's all a model is.
exactly, but that's how we
Yeah.
was
So my mental conception makes more accurate predictions than yours does.
and you are completely right in that part. You know why?
So then my model is better, and so we should use my model to understand the world around us. It is better because it's more true. It makes more accurate predictions.
No, that's the problem. It doesn't. Look, the problem
It
is that
does.
we live.
I just told you one. I just told you one explicit prediction.
No, just all what you're saying is schematic. All models, all predictions, all how it works because we was teaching like that since we was a little kid. Remember, let's put it this in occasion. If we was teach from the beginning, from the Bible, let's say an example. This is an example. Just listen to me for just a minute.
Quite literally was.
Yeah. No. And they change it. That's the problem. And we was all teach as a little kids that God created the heaven and the earth, and He created it.
That was quite literally taught to me.
And do you read it?
Yes.
Yeah. And knowing that what God have in that Bible, you still believe that the world is round?
Yeah.
That's impossible to
My
believe.
whole
that.
life, even when I was a Christian, even I believed in God. I believe Jesus
because
died
the
for me
people
for
are
my
confusing.
sins. Everything.
People are confusing.
I repented.
The globe that by NASA and but the Bible said they're putting all together. I see people, Christians that goes to church, and they still say, "Yeah, the world is round." And I say,
So Nelson,
who taught you that?
let's take your hypothetical.
The NASA.
It's not NASA. So let's take your hypothetical. The hypothetical that where everybody is just only taught the Bible from the very beginning. Nobody ever teaches science or anything. Now, if somebody asks you to figure out without using the internet, well, you wouldn't have the internet without science, but without using the internet, without going out and with a stopwatch, if somebody were to ask you to figure out how long is a sunset in Ecuador on September 21st, would you be able to tell me the answer? Would you be able to figure that out?
That goes out of the question because
what do you mean that goes out of the question?
Because remember, you're just saying it. If we go only by the teaching of the Bible and God, they will not even ask that question.
Because why not? I mean, it's a reasonable question to ask. I mean, they're like,
about that. You know why? Because
I don't care what they're teaching about. I'm just asking, could we figure it out if that's all we knew?
No, that's the thing. Don't compare globe with flat. People that believe in flat,
Nelson, I'm not bringing up the globe at all. I'm just saying, look, under your worldview, if nobody knew any science, if we only knew about the Bible, could we figure out how long a sunset is in Ecuador on September 21st? Is that something that we could figure out using your model, using this description that you get from the Bible?
Because you're still calling it sunset.
That's just what the word is for the phenomenon where the sun appears to go below the horizon.
And that's the problem there.
It doesn't matter what the word. Okay, so then could you tell me how? Could you tell me how long it would take for the sun to appear to go below the horizon? Can you tell me how long that would take?
I do that because I don't believe in a round globe.
No. It on your model. Could you figure that out?
It doesn't set.
Well, but it does appear to do this. We can see that with it. Yeah. So I'm asking, can you figure out how long it takes for it to appear to do that?
We can definitely, if we start measuring when the sun goes farther away. It might have.
Without making any measurements, just based on the model alone, can you tell me how to do it?
The pilots, what map they use?
In 1892, they were using globe maps.
Yeah, check it out. The glacier maps.
All maps that were being used in 1892 were projections of a globe.
Projections? As it is. It say there.
Yes.
Read it.
It's a projection of a globe. Do you want? Actually, I have something fun. Do you want to see something neat?
Yeah.
Yes.
Okay, one sec. We put on a green
All right, everyone,
screen.
tap that screen. Let's run it up to 150,000 likes. If you want to help out the live, everyone, share the live, copy link, send it to your friends. Everyone, you can support Venmo, Cash App in the bio as well. Make sure to check out Gifting Blitz as well, everyone.
Even the pilots use a standard glacier map to travel when they fly in planes. They don't use a globe model.
Oh, hold on. It didn't work. One sec. I'm just trying to set my green screen.
And you can ask any pilot if they had to put their nose down when they go in and flying, and they say no, it's all flat.
Oh, come on. There we go. Oh, why isn't it working? Sorry. Let me try one more time.
Thank you, William. Yep, the sun will rotate around the flat Earth. When it's in one side, it will be daytime, versa versa. Yep, you're completely right. And you can see that in the Gleason map in 1892.
There we go. Okay. See that behind me?
Yep.
That's a globe in the Vienna National Library from 1697.
Okay.
They knew that it was round back then. They have actual globes. It's a physical globe from 1697.
And they put that there in 1697, or they just added number.
The globe was built in 1697. I don't know when the National Library was built.
And that's your proof?
Well, I mean, certainly people have been using a globe for longer than, I don't know, whatever you said, 19 whatever.
1892.
So this is older than 1892.
You can see it in the Egyptians and the Mayas and the.
I mean, this is older than 1892. This is from 1697.
Oh, yeah. The map that I'm just talking about is showing you the December collapser and the June collapser when the moon and the sun is moving, when the sun is getting closer and when the sun is getting farther away of distance, when it's winter time and when it's summertime. It will show you. I don't have a picture to show you here, but you can maybe look it up there, an 1892 glaciers map. And
So why do we have a globe from 1697?
Do you know how people are in sciences right now trying to convert everything into the.
So have they been doing that for 300 years?
Of money.
Wait, have they been doing that for 325 years?
Do you know how many billions of money
How many billions of money did scientists have in 1697?
Well, I don't know. I don't know, but you know how many tax money they've been taking from people?
Which organization? Are you just talking about scientists in general?
Let's say NASA only. NASA only. Forget
about 20 cents per person per day.
But NASA
about 20 cents per person per day.
Yeah, you put in it. How many billions?
About 20 cents per person per day.
No,
we can work out the math if you want. I don't know what the number is off the top of my head.
Billions of dollars that they use just to tell us that they're drowning inside the space.
You gave them 2 dimes.
Per person.
Per day, yeah.
Yeah, give me 2 dimes
per person per day.
Give me 2 dimes per person to see if I'm not going to be rich in a year.
You would be rich.
Yeah, you as an individual would, but we're talking about a governmental agency
that employs tens or hundreds of thousands of people, I think.
Yeah,
I don't know what you're talking about, bro.
To lie to us.
What do you mean to lie to us? Can you give evidence?
Can you name? Yeah, please.
Yes. Right
Go
there.
ahead. Go for it. Give us evidence, Nelson.
Talking about the Earth is flat, and they're saying it's not. They're supposedly going to space.
And what's the evidence? What's the evidence that you have, Nelson?
What about the moon landing?
What about it?
Do you think it's true?
Yeah. What about it? He actually is laughing at us. Yeah. That's ironic.
It is ironic to think that the moon landing was true.
How?
I mean,
and where they put that rover,
pictures?
The car. Oh my God! Here we go with pictures of cartoons.
What if we have video? What if we have physical samples? What if we left stuff on the moon that we can bounce stuff off of?
Tyronda, thank you so much for the $5.
It wasn't 1965. At least know the conspiracy. It was 1969.
Okay, 1969. Close enough. 1969, and you think they have all these videos and all these pictures? They did that.
We literally had cameras were invented.
Rover. Oh, so you're saying that
cameras already existed?
Yeah, cameras literally existed. Dude, this guy, what is he saying, bro?
Dude, you're talking about that. You were saying that debate. This is a night debate. You're talking about that little machine that landed in the moon had a rover.
It wasn't a little machine. How big do you think the lunar landing module was?
Put the pictures there and see how fake that looks. Foil.
You know the lunar landing module is the size of a room, right? It's the size of a large room.
And you saw how it was designed?
Yeah, it's quite big.
Yeah, and you think that was that can land in the moon from Earth?
Well, it took a rocket there.
Yeah, and it landed in that piece of paper foil landed.
Well, it's not. It's aluminum and steel.
Foil.
It's not just foil. It has an aluminum. I think it has a steel frame with aluminum siding, and it's covered
no
in foil.
When they land, no marking.
Sorry.
When they land, they didn't the dust and the whole that flame that it was going down and landing there is no.
What are you expecting?
So the flame from the thrusters going down to land, no hole was created.
Why do
no
you think
dust?
that it would need it? That it would create such a huge crater or whatever?
Why not?
Because the moon's gravity is very, very weak, so you can land very, very slowly. You don't need powerful rockets to do so.
So you think that the sun was made before? You said the sun and the moon and all this planet was made before the Earth.
No, the moon was created after the Earth.
What about the sun?
The sun existed a little bit before the Earth, yeah.
Before the Earth?
A little bit.
Oh, but God said in the fourth day that He created the light.
God also says that we're all inbreds descended from Noah and his 7 other family members.
So God wanted incest to happen because He only created 2 people, right?
Well, in that time, yes. How are you going to start something?
Okay, so God is against incest. He thinks it's sinful, but God wants sin to happen.
How you multiply?
God wants sin to happen? Is that your view?
No, not my view. But I say in that time needed to happen.
So incest wasn't a sin then?
By NASA and by science, we came from a speck. We came from
so
nothing.
Nelson, it wasn't a sin then?
In that time, no.
No, okay,
Because
so the moral law of the Old Testament didn't apply at that time.
Also, why aren't we inbred? Why aren't we like all like decrepit, like disgusting monstrosities if we all descend from the same 2 people?
And then why we not monkeys?
We are primates.
Why am I not my cousin?
No, why why don't you see a monkey becoming a person?
Why don't you see my cousin becoming Parker?
You can.
What? Dude, Nelson, get in touch with reality, my guy.
No,
the
man,
point that I was making is that you think God wanted us to engage in sin, and if you don't think that the moral law applied at that particular time period, what was grape wrong?
The problem is that in that
Nelson was grape wrong in the Garden of Eden.
The Garden of Eden was Adam and Eve, the first ones created there, and they needed to
grape
multiply.
wrong in the Garden of Eden?
Who?
Is grape wrong in the Garden of Eden?
Who's grape wrong?
Grape. Take out the G because we're and think about the last 4 letters because it's TikTok TOS, so we can't say the word. Right? Is grape wrong in the Garden of Eden?
Well, I know what you're talking about. Well, he was. Well, that's another thing. You was in the Bible.
I think it's a yes or no question. I think I think you'd say yes, right?
Yes.
Yes, it's wrong. So do you get that from the moral law? But the moral law says that incest is wrong. So apparently here God wants us to sin.
Oh my gosh. You keep going back to morals, and that time it was no sin. So in that time, the only way to multiply.
So how do you know what's considered sin and what's not? The moral law?
No, that was after the fact. That's why.
Oh, okay, so if the moral law doesn't apply yet, is grape okay?
In that time, you needed to do it to multiply. You don't understand that
Wait
part?
a minute. But what about
Bible,
post-flood?
The flood?
Yeah. Why didn't he just leave more people alive?
Wait a minute. Now, thank you for bringing that up about Noah's flood. How Noah's flood work in a globe model?
There wasn't a flood. It's not real.
There wasn't a global
it's a story.
flood one. Yeah, but like what did God do with the innocent babies?
What innocent babies?
There were babies that existed at the time during Noah's Ark, right? So when God flooded the planet and drowned everyone, God drowned babies. Why did God drown babies?
Well,
I wouldn't drown babies. I don't know about you.
Yeah, I mean, if he wants to get rid of their existence, why didn't he poof them out of existence rather than literally fucking drowning them?
Well, why little kids have cancer?
That's a great question.
Great fucking question.
Yeah, but that's nothing to do with God.
Well, okay, then why? Okay, so there's something that exists in the world that was not caused by God?
Wait, did God cause the flood?
Yes.
So God
Did
literally
God
drowned
want
them.
did God intentionally drown babies?
Well, in that time,
Yes.
I say yes.
Okay.
Yeah. And you worship him.
But yes.
You worship someone who drowns babies.
To be fair,
the
if there
problem
was an
is-
all-powerful being, even if it drowned babies, I would worship it too because I'd be afraid of being drowned, right?
Yeah.
Exactly.
You don't want to get tortured, right? Oh, so you're just doing it for fire insurance.
No, not for fire insurance. The problem is that in that time, remember
That
time was not
sounds
a lot
like
of
fire
people.
insurance to me.
It was not a lot of people by that time. You guys talking about?
Oh, it's okay because it's not a lot of people. What?
Well,
That's so delusional.
The people that he was there, it was terrible people, and
Even the babies, right?
Well, the babies, sometimes people like what happened with Hitler. Let's talk about
What?
Hitler. Then.
He
killed-
was a bad guy. Yeah, he was a bad
killed how many
guy.
people? How many people he killed?
Something like 13 million.
Here we go. And you think that was good? That people allow him to kill all those people?
No, but
Okay.
Hitler was a bad guy. He was evil. Is your God evil?
So,
Yeah, and
for
also,
some
did
people-
we have
for
the
some
ability to
people-
stop them at that point? Right? God's all knowing, all powerful.
Nobody's
he can literally,
stopping.
he can literally snap his fingers and boom, it's done. Why didn't he snap Hitler away? Why didn't he snap
couldn't.
Stalin away? Why didn't he snap Mao away? Pol Pot, any genocidal dictator that ever
yeah.
existed, Jeffrey Epstein. Why didn't
Yeah.
he snap them away? If he
For the freedom of
snapped them
choice.
away as it relates to Noah's Ark, why couldn't he do it then?
True. It's a lot of stuff that we don't know. It's for sure. It's a lot of stuff
what we
that
do
don't
know
in
is
this
that-
earth. Bro,
What we do know is that the Earth
No.
is this shape.
That's what I was gonna say. It's
Ah,
not
and
this,
for me,
and it
the
is
earth
that.
is in that shape. But it's not even that shape neither, actually.
Yeah, it is.
By my understanding, flat earth is not like that neither.
Yeah.
know, they
But
put it
that's because the
like
Earth
that,
isn't
like
flat.
it's not.
That's the shape. This is the shape of the Earth right here.
Yeah, and the water is just holding by gravity.
Yes.
Yeah, I believe that. Yeah, of course, is the water is holding by gravity, and the fishes are flying, are swimming
Nelson,
there
is this
like
your
that.
model?
No, it's not my model neither.
No. So,
No.
so what does your model look like?
My model of Earth is different than that one and that one. Both of them are wrong.
Okay, so like, why does this model make accurate predictions about the world around us?
it doesn't actually, because
It
you can
does.
see.
What about the lengths of sunsets? The 2-minute number, you can
Here we
do
go
that
with the
explicitly.
sunset.
No, I mean, like, that's an accurate prediction, right? It's really easy to grasp. The Earth rotates once every 24 hours. In the case of Ecuador, on September 21st, the sun goes straight down, and because it's on the equator, according to our model, the Earth will rotate 15 degrees per hour. The size of the sun in the sky is half a degree, and so you can figure out that it'll take precisely 2 minutes for it to go above the horizon to below the horizon. That's an accurate prediction of my model. I'd like to see any accurate predictions made by your model.
Yeah,
I'd
the
like to
thing
see
is
any
that
accurate predictions.
I get it, because I'm not. You well study in your model, and that's how make you smart in that area.
Why aren't you well studied in your own model?
It doesn't mean it's right.
Well, it makes it better than your
Because
model.
be smart
If
in
my
one
model
area.
makes
To be
predictions,
smart in computers, it doesn't mean because somebody else that is not smart in computer, I know everything and that person don't know everything. The problem here is that you're so smart in that area that you know the mathematics, how the computer works and all this stuff, but it doesn't make sense.
He's quite literally a mathematical physicist. Quite literally.
he doesn't
has
care.
a PhD.
It doesn't matter to him.
Yeah, but it doesn't matter, because it really doesn't matter, because it doesn't prove nothing. Because
Well,
it just proves.
okay, Nelson, can we back up just a minute?
He believed in the globe. That's
Nelson, can we back up a minute? So let's say that there's something. Let's say that we like see. I don't know. Let's say that we go to like Russia and we see like a new thing we've just never. It's like a glowing ball in the like floating in front of us, right? It's just like a glowing ball, right? And it's like moving randomly or moving in apparently random ways.
Mhm.
Let's say that I give you the explanation, well, it just does that. And then you give me an explanation that says, actually, it does that for this reason. And because of this reason, it will move in this way it'll move in this way at some point in the future. If it then happens to be the case that your prediction is correct, doesn't that mean that your explanation is more likely to be correct?
Yes.
Okay. So you're totally on board with the notion that if you have a model of how a thing works and it makes good predictions, then it's more likely to be correct than a model that doesn't make any predictions.
Yeah,
so why doesn't that apply to the Earth?
You know why? The reason is because they're not exploring. The NASA and the government is not exploring flat Earth models. They exploring globe models.
I'm talking about just you and me right here. I don't care about NASA. I don't care about the government. I'm just asking, look, we have two separate models. Which model makes more accurate predictions? It sounds like mine does.
Yeah, by your prediction, yes.
Yeah. Well, I mean, you agreed if there's just like a random glowing orb in front of you, the model that makes more accurate predictions is the one that you should believe. So why don't you believe the globe model?
Because it doesn't make sense at all. If it's in the computer, yes, it does make sense. But we cannot get you need something to hold water.
Yeah, gravity.
Gravity doesn't. That's a myth. That doesn't. Gravity.
What do you mean it's a myth? Why is it a myth?
Why?
Gravity's a myth? Why do you think it's a myth?
Well, let's talk about that. Water is contained by a sea level, right? Sea level makes water contained, right?
Sea level doesn't contain water. Sea level just tells you the level that the water's at.
What's sea level then?
On average. Sea level is the height that water is at on average. Sea level is the height that water is at on average above the bottom.
How can you measure that in a round Earth?
Sea level it's just defined to be the height that water's at. You're not measuring anything. You just say, well, if that's where the water is, that's sea level.
Yeah, and how the water is containing?
It's contained by gravity.
No, it's impossible.
Why?
It's impossible. That's the problem. It's impossible.
Why is it impossible?
By gravity, because nothing else is held by gravity. You got birds.
Wait, you're held by gravity.
You're not.
Wait, yeah, you are. Why can't you fly?
Well, why? Because I got weight.
What do you think weight is?
It's not gravity.
It is. It's literally the force of gravity pulling you down.
Pulling me down?
Mm-hmm.
If it's pulling me down, why the fishes are swimming and not pulling down?
They are being pulled down. There's a buoyant force pushing them up as well. That fish can sink, by the way. If you attach lead weights to a fish, it'll sink.
Of course, because you're putting weight.
Because you're changing the gravitational force without significantly changing the buoyant force.
You're talking about a fish. A fish or a shark is swimming in the water, but the water is still standing in the same place.
Well, I mean, they're pushing the water out of the way, of course.
You need something to hold. Like you put water in a cup, it stays level in that area.
No, it doesn't. Have you ever looked at a cup's edge? It curves up a little bit because of surface tension, which is a force.
It's the glass.
What?
Nelson, you can literally take a water bottle and go like this, like really, really fast, and the water is going to stay in the cup, right?
Yeah.
If you spin it in a circle, even though right, the water is tipped upside down.
Yeah,
So it's held
before.
even by that, in that context, if there's a context of spinning.
Yeah, and then what about storms?
What about them? You mean how they rotate one direction in the northern hemisphere and another direction in the southern hemisphere?
Yeah.
Yeah, so that the Coriolis effect. That's why hurricanes rotate one direction in the northern hemisphere and the other direction in the southern hemisphere. How does it work on a flat Earth?
Yeah, well, in the flat Earth, because we're not moving, they have different rotations.
Why is it that
we're going 1,000
hold on,
miles
why
per
is it that
hour?
hurricanes never cross the equator on a flat Earth?
Are you serious?
Yeah, why do they never cross the equator?
Well, do you see even how the weather works?
Wait, you should answer the question.
Yeah.
Okay, so what's the answer to the question?
I don't have no knowledge of the equator.
Well, I mean, there's a place like called Ecuador or Equatorial Guinea, which we call the line that connects them, the equator. So why is it that storms that are on one side of that line never cross over to the other side? I'm talking about like hurricanes. Why do they never cross from one side to the other? No idea. But I do know. Okay, well, I can tell you why.
Okay, tell me.
It's because they're rotating in one direction, and the winds that would be required to rotate them in the other direction from the Coriolis effect would be far too strong, and it becomes an effective barrier from crossing. There's a Coriolis effect that is in the opposite direction on the two equators. Sorry, you can't see my hands. One's going like this, one's going like this.
Yep.
And so because the equator or the Coriolis effect has forces in opposite directions, that barrier that provides an effective barrier between storms that are rotating in one direction and storms that are rotating in the other direction, north and south of the equator.
Yeah, but we're north and south, and then we have if we're spinning 1,000 miles per hour, how we get storms in different directions.
That's a non sequitur. I don't see how those two statements are related at all.
Well, they rotate.
Oh, you're paused right now. Alley Cat, thank you for the subscription.
Oh,
I
sorry,
appreciate
they're
it. Thank you
rotating
so
in
much.
different- You know, let's get another flat Earth in the line. Thank you for answering all those questions, though.
Oh, you're done debating?
If you want to keep going, we can keep going, but you got more people in line here.
Sure. I mean, if you want to keep going, you can. I'm not quite sure if people would be flat
I see a lot
earthers.
of people, little people that want to talk to here.
Yeah. So I can try to add someone up. If we don't get someone up, you can come back in the request box if you'd like.
Yeah, I can do that. Thank you, guys.
All right,
though.
for sure, man. All right, have a good day.
Yeah.
All right, let's try to get to the next individual. Only send a guest request if you think that the Earth is flat. Everyone, tap that screen. Let's run it up to 250,000 likes. If you want to support us, Venmo, Cash App in the bio as well. You can gift Blitz here on the live as well. Yo, what's up? How old are you?
I'm 22.
For sure. Do you think the Earth is flat?
Yeah, 100%.
What's your birth year?
10th of September 2001.
For sure. Yeah. So why do you think it's flat?
Just observation.
Really? So, like, can you explain to me sunsets?
So in regards to that, right, I don't truly understand how the flat Earth works because there isn't the research. I believe it's not on a. It's not researched by the correct people. Like, you don't have people at NASA researching flat Earth because why are they gonna do that? They probably do have the schematics of how everything works, how the Earth really runs, but that information is concealed. So you have your basic flat earthers, flat Earth scientists who are not essentially real scientists, but know how these things work. But they're not coming from real government places that are saying these things. So it's a weird one, honestly, because it's like gaslighting, essentially. It's like you guys are basically, you have people to refer to when it comes to proving globe Earth. You guys have references. You guys can go to NASA. You guys can go to the space station. But then when it comes to us, because we don't have people in those high places, right? Us flat earthers that we want, that people who have the resources
Or any observational proof.
Again, observational proof is, to me, it's still reliable. Because we can see
Why
What
isn't there
observational
anybody-
proof? Go ahead.
Why isn't there even anybody who has like a bachelor's degree in physics? Why isn't there anybody like that who's a flat earther?
It's well, again, if you base your research, right, and your knowledge on falsified lies, then of course you're not going to get the full picture, are you?
Well, why isn't it the case that any flat earthers go to college, get a bachelor's degree in physics, and then stay flat earthers? Why doesn't that ever happen?
Being a flat earther is not. It's like you need to understand.
Well, because when you do a bachelor's degree in physics, you do experiments and stuff, right? You do experiments and you run tests and you do data analysis and stuff like that. Like, that's all part of the degree.
The thing is, right, but when you're doing that based on falsified lies, of course it's going to make sense because you're doing it.
So you're testing things. That's the whole process of the experiments. That's why you do experiments when you do, like in your undergrad, you test these things. You test gravity. You test,
testing gravity,
like
right?
Pressure and buoyancy. You like test all of this stuff. You do experimental tests to confirm that these things are real.
Example, gravity, right? What's the saying behind gravity?
I don't know what saying you're talking about. Are you talking about Newton's universal law of gravity?
Yeah.
Newton's universal law of gravity. It's what it's called.
Yeah. So we can't prove gravity, right? You gotta just associate a word for something else. Like, from what I know, all it really is mass and density. It's our weight. And so you guys associating this imaginary word called gravity, right? And expecting us to believe.
I mean, all words are made up. I don't.
I'm just saying you're associating something, an unseeable force with a word that's something that we cannot prove. When
all forces are unseeable.
Again, I can associate gravity with mass and density, right?
No, it's not enough.
That's not enough. Why is it not enough?
Because there's a force there. Mass and density don't give you a force. That doesn't tell you the direction of motion,
Where's
for
the
example.
force? Where's the force?
The force is a description for the phenomenon where we observe the acceleration of two objects move, or where we observe a cause to an acceleration of two objects, or one
So where's
object,
the
perhaps.
force behind? Yeah, but where's the force behind gravity? Where's this?
Gravity is the name of the force.
Okay, so how can we observe this force?
Yeah, we can, for example, take two large spheres, put them perpendicular to two small spheres, and we can observe the two small spheres rotate towards the two large spheres.
So I'm confused. Are you talking about magnetic poles?
Nope, I'm talking about gravitational pull.
Gravitational pull.
Mm-hmm.
So all right. So again, so this just sounds like you're associating a word to things we can observe once again.
Yes, that's how language works.
But you can't observe. We can't really observe gravity, right?
So we observe the effects of gravity in the same way that we observe the effects of magnetism, or we observe the effects of electrostatics, or we observe the effects of friction, or we observe the effects of, like no force can be seen, but we can observe the effects of that force.
Well, again, if I was to see and say gravity is nonsense, you guys couldn't. You couldn't
I
really
could give you experiments that prove that it's true, prove that gravity is a real phenomenon.
I mean, it's like what you guys are doing is I see as plagiarism. To be honest with you, I see as plagiarism. It's some form of plagiarism. You're essentially associating the works of mass and density, and
mass and density don't get you to a direction.
Again, you're associating this with gravity. Gravity in itself is
no. Gravity is not just mass and density.
Okay, this is what I'm saying. This again, I don't even believe gravity exists. I believe you guys are associating a force that has nothing to do with what you claim gravity has. But besides that, how can you guys prove that the Earth is a globe?
Well, the fact that gravity exists means that the Earth has to be a globe. But beyond that, we could look at sunsets. We could go look at photos that we've taken of the Earth. We could go look at the lengths of shadows on sticks that are pointing into the sky. We can look at how long those shadows are. We could look at the angle that two buildings deviate from each other. So if you have two buildings that are far away, two tall straight buildings that are far away, you can actually measure the distance between the top and the distance between the bottom, and you'll find that the distance between the top is bigger. There's a whole bunch of ways that we could show that the Earth is a globe.
The thing is, though, you're using globe Earth schematics, right?
I'm not using globe Earth schematics. I'm just talking about collecting data with regards to buildings, or collecting data with regards to the lengths of shadows of sticks, or collecting data with regards to the duration of sunsets. Any of these things, I'm not assuming globe Earth or anything. I'm just collecting data and seeing which model it's more consistent with.
All right. So in regards to you guys said something, you've seen photos of space, right?
Yeah.
How can this be proven without bias?
Well, you can go look at the literal plastic photos that are about 20 miles away from me.
But how can I be sure?
Not 20, sorry, 5 miles away from me. You can just go look at them. They're physical objects. They're physical pieces of film.
Yeah, but the problem is, how can I be sure those pictures are really Earth, though?
Well, you can see the shape of Africa on it, for example.
That doesn't. How do I know those pictures are real?
What's the alternative?
What's the alternative?
Mm-hmm.
Well, we have more than enough resources to essentially make what's it called? Commercial space travel. I believe that's one way we could get to the bottom of this.
There is commercial space travel. There have been billionaires that have gone up to space in the last 5 years.
No, you see, when the common person, right, just like how we can buy a plane ticket for a reasonable price, when the average person is able to buy...
It's a little bit harder to get to space than it is to get to 5 miles up.
Yeah, but the thing is, right, when the average person is able to buy a ticket to space, right, when commercial space travel is available on a global scale, on a reasonable price, that is when I think we'll be
Did you just say a global scale?
Yeah, most definitely. Because it's like, if you have a bunch of rich people buying tickets to go to space, it's not, you think people with huge, vast money will have a problem telling these.
Wait a minute.
people-
Wait, why is it on a
Wait, let's
global
just-
scale?
Yeah. Let's just clarify that. Yeah.
on a global scale.
Yeah.
Well, because
So
I
sorry,
believe-
what shape is the Earth?
flat?
But it's on a global scale, right?
Yeah, it's on a global scale.
Again, no. You see, that's you're trying to use word. Again, when I say a global
Wordplay.
scale-
You're the one. Is that? I think that's what it's called, a Freudian slip.
Oh, bro, do you want me to say a flat earthly scale? Like, come on.
Yeah, do it. If you're really gonna believe this stuff, man,
Again,
commit to the bit.
if you know what global means, it's just talking about everyone.
On a
Global means-
pancake scale.
Anyways, yeah. But if I believe once commercial space travel is available, which I also think will never be available, they will never make commercial space travel a thing for everyone because they know if people were able to buy.
This just sounds like speculation. It doesn't sound
again.
like proof.
This is not speculation, bro. Come on,
It is speculation. You literally just said, I think that they will never make global space travel available. It's
Bro,
speculation. You just said, I think.
When did they master space travel? When did they master it?
It's
what
still
year?
not mastered.
No, let's say when was it? When did they go to space first
For the
time?
first time, like 59 or something.
1959.
Yeah.
So it's
That's less than a
2000
lifetime ago.
Yeah, it's 2023 now. By now, we should have commercial
Why?
space travel.
Do you think that
mean,
we've...
why?
Wait. Do you think that like we've mastered airplanes? Do you think that there's going to be no more improvements to airplanes?
I mean, there can be improvement, sure, but when it comes to space travel, it should be commercial by now on a huge scale. Because it's again.
So hold on. Are laser weapons commercial?
Laser.
Do we have like commercially available laser weapons yet?
Again, that's irrelevant because that
No, it's super relevant because the military has laser weapons and lasers were invented in 1954, which is 5 years before anybody went to space. So why aren't those commercial?
I mean, again. So if that could be undisclosed, though, what if they?
Well,
have
so
that,
why isn't it commercial?
Again, this is what I'm saying, though. That's irrelevant. What you're saying is irrelevant because I'm talking about.
It's identical to the argument that you're making.
It's not necessarily because we're talking about.
It's literally identical. Why don't we have laser weapons when lasers have existed for longer than we've had space flight?
Why would the government allow?
I want a ray gun.
Why would the government allow a public usage of allow the public to buy laser weapons?
Why would the government allow the public to go to space?
Again, does the government allow people to buy rocket launchers just like they can buy guns in America? Is that a thing? Can you buy a rocket
Probably
launcher?
in some states, yeah.
But realistically, no, you can't. So you guys
Hold on, let me Google. Can I buy a rocket launcher?
So you just
guys
say like
trying-
nukes, like
So
they
you
don't allow
guys,
us to buy nukes.
you guys trying to
Yes,
say what?
it is legal under some conditions to buy a rocket launcher.
That is unbelievable. I actually think that is a travesty. Holy shit. Welcome to the
anyway.
United States of fucking America. You can buy a goddamn fucking rocket launcher, bro.
It requires a Class 3 tax stamp, but otherwise it's legal.
But what I'm saying
That's
is,
wild, bro.
what I'm saying is, you guys gave a reference like, oh, so why isn't commercial buying of laser weapons available? It's like, bro, the government's just not for our own safety. That's just not reason. That's not.
So maybe for safety is why we don't have commercial spaceflight yet. Ever thought about that?
Again, that's
No.
nonsense. That's nonsense.
It's nonsense.
It's
Why?
nonsense. Because it's space. What
Space
safety?
is not very bro. Space isn't safe.
I don't even. The
It's
thing
not
is, that
friendly to human life.
I don't believe in the space that has been portrayed. Though,
You don't believe in space?
I don't believe space is the way that they're portraying it. Like, oh, we're just weightless.
So you do believe in space. You just believe it's different than in the way they portray it.
No.
So when you look outside, right, and you look at the night sky, right, and you look in a telescope, right, what do you think that you're seeing?
Well, again, I believe we're seeing pockets of literal space. Yeah, when we look up to the sky, and not spaces in the way that you say. Because put it this way, how can rockets work in a vacuum? Like just simple.
I made a video about that.
Well, but for me, it's nonsense. It's nonsense. How if they're claiming space is a vacuum, how can rockets? It's nonsense.
I have a YouTube video to show you of a rocket working in a vacuum.
But then again, no matter what explanation you try to.
What if I just show you it happening?
Again, it's still unreasonable. Can you?
I can just show you it happening.
Yeah, he's just gonna show it to you real quick, bro.
So okay, sure thing.
Everyone, in the meantime, tap the screen. Let's run it up to 250,000 likes. Share the live, everyone. Let's try to get to 1,000 shares.
Okay, so hold on. Oh, this is a really long video. One sec. Let me get to the the relevant part, right?
Just give it a second.
So,
If you want to support us, Venmo,
do you
Cash
want
App,
to make me
Venmo,
big,
as well as you
Parker?
can gift Blitz. I have
make
no
me big?
ability to make you even bigger. It doesn't give
You
me
should
that
be able to.
ability.
Really? Mm-hmm. Okay, so here.
Which one is it? If you can.
It's the one that looks like like 4 squares, just kind of like going out, like going like this. If you tap on my screen, it should be like 4.
I only
like
have panel grid. That's it.
You should, if you tap on my thing, it should pop up with a few options, right?
Oh,
if you click on my
expand?
box. Yeah. Sweet. Right. So this is a. Let me just back up just a minute. So this is a vacuum chamber in here. The vacuum chamber is there. Hold on. So here's the pressure gauge. It's hard to see, but it's reading 0. It's like all the way back. Here's the rocket, and we're going to measure the force that the rocket pushes off of the vacuum with. See the little dial right there? That little. Oh, sorry. I just wanted to actually go. Oh, is it not actually going? Here we go. Okay, so the rocket's not actually burning. Hold on. There's one of these clips where the rocket actually lights.
New ability unlocked, chat. New ability unlocked.
Is it?
Where's the?
Here it is. Sorry. Here's a version of it lighting. The rocket motor failed to light in that case. So he's resetting it. Here we go. See it going? It's hard to see. There's gonna be a slow-mo version in a sec. Here we go. Hey, see how that force gauge is moving with the rocket going in a vacuum?
Bro,
see how the force gauge is going? There's a force gauge, and it's pushing off of nothing.
Bro, that is.
See where the force gauge is?
Bro, that is uncomparable. That experiment.
Oh, but it's in a vacuum, my guy.
But that's a small. That's on. Not only is that on a small scale. We're talking about.
Oh, it's too small though.
We're talking about the so-called vacuum of space, and you're trying to conduct a.
It doesn't. It's a vacuum chamber. It's a vacuum chamber with a rocket in it. I thought you didn't. Isn't that good enough?
That's no. That's not good enough at all.
So why not? Why would it work in a vacuum chamber on Earth with a rocket, but it wouldn't work in space?
Because if we're talking about the so-called vacuum of space, if you're using rocket, we're talking about space, which is infinitely vast. By the way, apparently.
Who cares how big it is?
It's just nonsense. It's just pure nonsense. You can try conduct.
It just sounds like you're saying nuh-uh.
So okay. So this is the thing though, which you guys don't understand, right? So you guys can use as much science. You guys can you can say that you've researched these things for years and you can come up with as many explanations, right? But the thing is with me, that information.
My imagination beats your science.
That information is as useful as discovering how a pen works. It's like you guys research things that it won't actually help you with anything. I don't research. I don't look into things.
So hold on. I can tell you all the lovely things that we figured out because of the research that's been done regarding gravity and stuff like that. Like, for example, GPS satellites rely on special and general relativity. We use those all the time to get from point A to point B. That's super useful.
No, I don't think you understand what I'm saying.
I don't think you understand what you're saying.
It's like I'm not saying science is I'm not saying science is not useful. I'm not saying that. I'm not saying science is not useful.
So it is useful in demonstrating that the Earth is not flat.
I'm saying you have your common science, you have your real science. There's real science that is out.
Does GPS rely on real science?
Again, if we're talking about common science, I don't have a problem with that. Okay, but when
I'm asking, does GPS rely on real sance?
Well, yeah. Well, all things rely on science in some way or shape.
Right. So what science does a GPS rely on?
What does that have to do with anything?
Well, it relies on special and general relativity, and it relies on satellites that are orbiting the Earth.
Okay. But what is so why?
How do satellites orbit the Earth if the Earth isn't a sphere?
I don't even believe satellites even orbit the Earth.
You believe in GPS, right?
I mean, sure, but I don't think satellites are what they portray.
So how does GPS work then?
Well, I'm not. Again, I believe they still work using satellites, but I'm not saying. I'm just saying that satellites are not orbiting the Earth the way that you would think. I believe that.
So what? How are the satellites in the sky? How do they stay there?
Well, again, I've seen multiple videos of satellites falling to the Earth and being connected to balloons. So
you've seen videos of balloons falling to the Earth. You have not seen videos of satellites falling to the Earth.
Have you seen a video of a satellite orbiting the Earth?
Yeah, you can literally see them with your eyes.
Okay, please show me.
There was a guy on TikTok who, during a TikTok live, had a telescope, pointed it at the International Space Station, and literally saw
Nixie. Yeah, Nixie literally did this.
So there was it wasn't Nixie who did this thing I'm talking about. He literally saw a spacewalk happening on TikTok live. It was an accident. He didn't expect to see a spacewalk. He didn't know it was scheduled.
Can you provide me
on a TikTok live?
Can you provide me a video of a satellite orbiting the Earth?
Yeah.
Honestly, I'd love. I've never seen a satellite orbiting the Earth, only in movies. So I'd love to see.
In the meantime, everyone keep tapping that screen. Everyone
on YouTube at this point.
Let's get to 500,000 likes, y'all. 500,000 likes. Keep tapping as well. Share the live.
This was a
copy
thing.
link a million times.
If anybody knows, and maybe I'll find it on TikTok rather than looking on YouTube. Oh, okay. Let me see if I can. Let me pull it up on TikTok rather than YouTube. One sec. Spacewalk.
I'm actually very curious. I've never seen a satellite.
Here we go. Oh no, sorry. This is just the photo. Oh no, I'm sorry. Sorry. Let me turn off the sound of my computer. I think it's Sebastian Voltmer. ISS. Let's see. So here's a photograph from his
a photograph.
A photograph, yeah.
So as for video,
oh no, I'm sorry. Here's the video.
Yeah, there we go. So yeah, much preferred video.
Okay. It's through his telescope, of course. So bear with me. Let me flip my camera. It's a very short video. We could just play it, but. So he's pointing his telescope. Yeah. So here you go. Here's what he's capturing with his telescope over here. It's hard. It's not really coming through on my camera very well, but there's a little smudge there. He's zooming in. This is processed footage now. So it's like cleaned up and stuff. So.
Bro, that is one of the fakest videos I've ever seen.
Oh my God, of course he thinks it's fake.
Hold on. What's this? This is directly coming from his telescope. What is it?
Bro, do you say it was enhanced or something?
This part now is processed to get more to get better resolution. But look at this. This is unprocessed. This is raw from the telescope. This part right here.
Michelle, thank you for the $6.
Now he processes it.
Thank you so much, I appreciate it.
Now it's processed, but it wasn't processed before. Again, it even says explicitly raw footage. What is it?
Bro, that does not look real.
Sorry, it's raw footage. You asked for a video. I showed you a video.
Okay, but again, how's that reliable?
Wait, so if you wanted a video, or if you were just going to say a video is fake, why did you ask for a video?
I mean, because the reason why I'm saying that is because the guy used a processed version.
No, he didn't. He processed it afterwards so that we could see it in more detail. Hold on. That's just what photographers do. This is raw footage. This part is raw. I mean, notice how it's really
how do you know it's raw footage?
I mean, we could just ask the guy if you wanted to DM him.
I mean, but how do you know? But again,
so if you're just going to say it's fake, then no amount of video evidence I could provide you would be real, right? You just say it's all fake, right?
I mean, I have reason to believe it's not real because again, he used processed imagery source.
He explicitly told you when it was raw and when it was processed.
But again, I see that as unreliable now.
So if I hadn't shown you that that the latter half is processed and that the first half is raw, you would have just believed it?
I mean, not 100%. I would have most likely have assumed that, it could probably be real.
Yeah, because you're going to say that every video I show you is fake.
Not necessarily, no.
That's literally what you just did. You just assumed it was fake.
Again, listen, if you can pull up another, try find another video.
Okay, let me find another video.
Yeah.
Let me go to YouTube. There's probably plenty. Video of ISS from ground.
Because again, I'm not saying satellites don't exist.
ISS through my telescope. Hold on, let me flip my camera around. It's a different guy. I'm just gonna skipping ahead. He has a solar filter on his telescope, by the way. So this is the sun here.
Okay.
A solar filter is just how it doesn't blind the telescope, right? So in principle, I haven't seen this video before. So in principle, we should see an ISS transit. So so here's, you see that? See that really quick?
Huh?
Did you see that? Hold on.
You see what?
Pay very close attention. See that thing fly across the sun?
Bro, let's be for real. Let's be for real.
There it is in slow-mo. Hold on. Let's make it bigger. Let's make it a little bit bigger.
Bro, do you is that really?
And let's look at the HD version.
Okay.
Oh, I can't go HD.
Do you think that will help? Sure.
So I don't know if you can see this. Oh, where'd it go? One sec. It's not a random speck. You can see that it has two lobes. Hold on, let me get it to focus.
Bro.
You can see that it has two lobes. There's a lobe down here and a lobe up here. And that's coincidentally there. Yeah, see? It even looks like the ISS.
Bro.
Just small.
Are you being dead serious right now?
I'm being dead serious.
What bro?
Let's look for another clip.
I don't know why he's not
coming from there.
I would suggest you look for another clip because that was outrageous.
You see it you just see it fly by?
What did I just see? What just happened then? No, show me, please.
See that thing?
Bro, what on is that a paper clip? Like what on earth? Like what are you trying to show me?
Did you see it again?
Bro.
Let me slow it down for you. Let me slow it down real slow.
That's a satellite. This is the best evidence you could produce.
This is literally the first YouTube link.
That's the best. That's the best you could. That's the best.
It's literally the first YouTube link. It's not the best.
But the thing is, though, I don't think you're being honest with yourself right now. I don't think you genuinely believe what you're seeing right now. I think come on. If
that's a little bit smudged. But see how it has a shape? See how there's a line in the middle and there's lobes on either side?
Bro, I want you to be dead serious right now, and I want you to be honest. Park, I want you to be honest too. Are you does that look like a satellite to you?
Here we have Jupiter. I guess this is this is
you guys are not being, you guys are not being honest. There's no way.
How are we not being honest?
What's this? Bro. What's this? What's this thing?
Again, another speck. What are you trying to prove?
Why does it have? Why can you see the solar? Where'd it go? Pause. Damn it. Pause. Why can you see the solar panels? The main crew area. Why does it look like that?
Fake.
Why does it look like
Because
that in every single video?
Because they faked it.
Bro, there's no way that's what you observed from what you just saw. Then there's
it's
no
a
way.
satellite, my guy.
Bro, you
satellite
saw
through a telescope.
Bro, you saw a ball, a speck of dust. Like,
what about this? What about this? What is this? What is this a picture of?
Bro, that's a blurred picture of a light.
Those are solar panels. Solar panels. ISS, my guy.
Bro, bro, be dead serious right now. How are you concluding that from? If you was to show that image right to a random person, what would they say? They would say it's a smudge. A
random person would see this and be like, "Oh yeah, that's a satellite. That's a space station."
Bro, you're not being honest.
If they wanted to fake it, why didn't they make it clearer?
That's a real good question. And what's this? What's this? Looks like the same thing, but from a different angle, huh?
Bro, so I asked you guys for
they just wanted to make it blurry.
Why does the smudge
the CGI
always
they
look
made
the
it
same?
just for fun? They made it smudged for fun.
Why does the smudge always look the same, bro?
That is
because it's fake.
So that's the best you guys could come up with, huh?
Literally the first video, my guy. You asked for footage of the ISS. I just gave it to you.
You should be
I took
appalled.
a picture of the ISS.
That's the best you can come up with. You're the one not responding to anything. You're just saying, "Nuh-uh."
I'm literally telling you guys,
Fake.
satellites are not what they are depicted as in the movies. And you guys are
So
not
here we have the
anything that's not.
ISS moving very, very slowly. We're going to get something a little bit more impressive in a second once we get to the peak.
I mean,
He's going to resolve it. Sorry, it's playing on
Trust
ultra
me,
slow.
bro.
I should
it's
slow it down.
CGI. It's CGI, bro. Trust me.
Speed it back
Bro,
up to normal.
the thing is, I'm not even saying it's CGI. It just looks like a ball.
You literally
a ball,
did. You said it's fake.
bro. It just looks like a ball of light. Like, I'll be honest, a random ball of light. Like, you guys are not showing.
What's that?
Real.
Sorry, that was terribly exposed. One sec. Let me pause it back.
Okay, let's see.
Oh, okay. So it
that?
looks like on my screen, it's very clearly like
What can
ISS
you
shaped,
see?
but
What can you
I
see
see
on that?
I see a
picture there?
lobe here, a lobe here. I don't know why it's like
Bro,
not focusing.
Be dead honest, because we got 4.1k people.
Yeah.
watching.
So
What
I mean,
can you see?
on my end, like my camera's not doing a great job, but maybe it'll actually be better in a second. But on my end, it's not really coming, or on the video, it's not really coming through. But you could go watch, you could go look at this video yourself, and you'll see that it's actually really good.
You see, you're like, bro.
No,
I
you could pull it up yourself if you don't like it. Point is that there's 100,000 videos of people taking pictures or video of the ISS. You can go look them. Are they all faking it or what?
Yeah, right.
They're all faking it. Wait, are they all faking it?
So the thing is,
Are they all faking it? You should answer that question. Are they all faking it?
Again, the videos that you show,
Are they all faking it?
All faking what?
These ISS pictures and videos, are they all faking it?
The funny thing is, I'm not even saying that the videos are fake. I'm saying the videos, you can't conclude anything from the image you show.
I mean, you see a very clear and well-defined shape in all of these.
Bro, we have just witnessed like 3 images that show a random ball of light smudged. Like,
I could show you again, but they're definitely not just a random ball of light.
I mean, you can show us again. Everyone can observe. It's just a smudge of light. A smudge on
like
the screen.
I don't know how dishonest you're being, but like
I'm being dead, bro. You're trying to say that you can see the crew
literally
panels
you
and
can literally you can. Okay, I'll pull it up again.
You're saying that you can see the crew panels and
No, you can see the solar panels, my guy.
the disc.
What is this? This is just a smudge of light, my guy.
Bro.
Yes, dude. He ate cheeseburgers before, right? And he touched the camera lens. That's why you see that.
Yeah, and this is the mayo, and that's the honey mustard. That's the mayo.
Yeah.
That's more honey mustard.
Yep.
It's like I don't know if you're being dead honest, right? You're trying to if you did not see that video explain, oh, this is apparently a satellite, from any random person's perspective, they would just say, what?
Actually, dude, it's an angel.
They would just say, what on earth am I? They would say, what on earth am I looking at? So when I asked you for video evidence, everything you provided was just, I'll be honest, it was terrible. I was expecting somewhat a clear video of a satellite.
I mean, I showed you a very clear video, and you just said it was fake.
None of those were clear, bro.
Literally, I showed you a very clear video.
Bro,
you just said it was fake, though. Like the very first one I showed you was super, super clear. You just said it was fake.
None of those were clear. If we're being honest with ourselves.
If we're being honest, I literally showed you a super clear video. You said it was fake. It was the very first video I showed you. You said it was fake.
Okay, so prior to that, right? I should show me others because I believe that first one was there was a.
You said it was fake.
Again, after seeing it was processed, I saw you show me over. I said,
well, part of it was processed, and then the first part wasn't.
I told you I would see the other videos for their face value, and what you showed was insufficient, extremely insufficient.
Yeah, so you're just gonna say everything I show you is fake or not good enough?
No. The problem is, right. Hold on. The problem is, right. Why is it that the first video that you showed me, how come it was quite clear for that person on
because they had a bigger telescope. They had a quite large telescope.
Okay, so I'm sure there's hundreds of millions of people with a bigger telescope.
Yeah, let me show you a picture, photograph of the ISS
video.
Well, I don't know how many people have captured the ISS in that great detail, like as amateur astronomers. I don't know if other people have done that.
Okay, so now you're saying there's one random amateur on YouTube that has.
Well, I don't know. I'm saying I don't know.
Okay, so now
I know that many people have taken photographs. Because it's a lot easier to take a photograph than it is to take a video, right?
So why do you think that so now if you know, right, if you don't know, if there's other video evidence.
Because this is the only guy I've heard of that's done it.
So
That's all.
okay, so then how can that person's evidence be reliable then? Would you see why it's fair for me to have a bias towards him?
But why do you automatically assume that it's fake?
Because he's the only person that we can that you can find and I can see.
Yeah, so why do you assume that it's fake?
Because he
Trust
showed
me, bro.
he showed a process image afterwards, and you're saying that
Yeah, he showed a process image, and we can compare the processed image with the raw image, right?
Okay, and he was and you told me he's the only one you know with that clear an amateur that has that much clear footage of a satellite. If you can show me
the
another
ISS.
person, again, if you can show me another person with a clear footage, just probably clearer than his or just the same, then that would be more reasonable. But right now, all you're saying is, well, this one guy who even had a process image of the ISS, right? I should take his word, and when there's no one else out there on YouTube that can provide the same thing, when the ones that you shown afterwards did not show.
Oh, actually, I think that here's another one using a much larger telescope. So let me just make sure if it's good.
Okay, let's see.
Oh, you won't like this. You won't like this because it's jiggling around.
Let's see.
Oh, but you'll just call it fake. Hold on. Okay, so here's... Here, we'll just play the whole video. It's taken a photograph here, but it's a video. So this is stabilized video because it's moving, right? This is stabilized video. And then he's compositing all of those to get this.
Yeah, bro. It's
fake. It's fake. Got it,
bro. That's not it. That is not reliable at all. It does not look real.
It's fake. Yep, I knew it. I knew it was fake.
Bro, you say that like I don't have reason to believe
it's fake. Trust me, bro. Please.
It's always fake.
Please, it's fake. Trust me.
Here's videos of people taking pictures of Saturn, ISS. Oh, that was the one that we just watched. ISS trends. Oh, this is from the guy that you think.
Can we get a trust
faking
me, bro, in the chat, please? Trust me, bro, in the chat, please. And as well, tap that screen, everyone. Let's get to 500,000 likes, y'all.
Instead of satellite, let's put ISS. There we go. I'm sure that, and we could keep doing this all day.
Reality is fake.
ISS 3 telescope. Here we go. Here's another one.
Yeah, that looks so real.
Reality is fake. Trust me, bro.
It's fake. It's also fake.
The thing is, right? The funny thing is, I'm not even saying that satellites don't exist. I'm not even.
No, you're saying that the ISS isn't real.
The way that you're trying to prove satellites are orbiting in space, it's just you're not showing anything that is.
I just showed you a video. Here's a guy photographing it.
Again, that is not hard.
Oh god, this is a long video. You look. There's no proof that'll convince you. That's what it boils down to. There's no amount of video evidence that you won't say is fake.
I mean, if there was clear video evidence, right?
I've shown you now 3 videos.
Again,
essentially, it has to look like CGI for him to accept it.
Again, those are.
That's a good point. Here, Nikon P1000 ISS solar transit. Let's see. This is just using a regular telephoto lens. So here's this. So he has a solar filter on.
All right. Okay.
So we're going to see the ISS pass in front of this, and I'll slow down and replay it. Oh, okay. So did you see it? It was really quick. He's going to slow it down. This is 1/5 speed. See it,
bro? It's like.
Here's the trail that's left behind. Now, what does that look like to you? Sorry, it needs to focus. Here he's tracking the motion even slower.
It's not clear enough.
This is the sharp.
It's a TIE fighter.
He's going to zoom in on the sharpest frame that he captured during the video. He's zooming in. That's actually a really good photo. It's not coming through super great on my camera, but suffice it to say, you can see that there's a solar panel.
It looks like a Chinese weather balloon to me. I don't know. I can't really.
Where's
tell.
the balloon?
Dude, this guy's actually.
It's not clear. It's not that clear. It's not that clear. That's why.
Where's the balloon piece? Why are there solar panels?
Hey, that's my conclusion, bro.
What
This is
Chinese
not-
weather balloon passes in front of the sun that quickly?
Again, this is not clear enough for me. This is
Okay,
not
so there's no amount of evidence. If it's too clear, you'll call it fake. If it's not clear enough, you'll call it a Chinese weather balloon. Got it.
It's not the ones that were, to be honest, the ones that were very clear were said
You
to
called
be
fake.
No, was said to be processed by the person who made the video.
No,
first.
only the latter half was processed, not the first half.
Again, so it's like
Honestly, this guy is just scrambling right now. He's scrambling.
You should,
So
you should
looking
like,
for
take a look at
answers.
the kind
Chinese
of
weather
evidence that you
balloon.
require.
So to conclude, look, I'm not saying
I don't think that you're concluding anything.
I'm not saying that satellites don't exist. I believe satellites exist, right? But I believe that it's either they're underground. There's some of them. We have underground satellites, underwater satellites, and also
They're
we
not
have,
satellites if they're on the ground. That's just,
And
that's just not what a
also
satellite is.
And also we have ones that are connected to balloons. I believe in these type of satellites, but satellites that are floating through space, I don't believe that is a real.
What's
thing.
that?
Where was that image taken from?
Oh, that's exactly the one I was about to show you.
Where was that image taken from?
As in, like, what was the location of the image? I don't know where this person's based. Their name is Tony Williams. They're in the UK.
How do you know Tony Williams is a reliable
They're in
person?
the well. So that's my point. You'll just call anything that you see fake.
You
come on.
show me random again.
David, thank you so
asked-
much for the $10
you
on
asked
Venmo.
for
Thank you so much.
amateurs. You asked for amateurs, so of course they're just going to be random YouTube videos. If you wanted something official, you would say, "Oh, it's faked by NASA."
But what I'm getting at is nothing's truly reliable.
Okay, so have you ever been to Australia?
No.
Okay, does Australia exist?
Yeah.
How do you know?
Because I've seen people, family members, go to Australia. On top of that, I could confirm.
They're lying to you, bro.
Hold on. No,
They're
the thing
lying
is, right, I could confirm it being real by buying a plane ticket to go over there.
But you haven't done it yet, so how do you know it's real?
I mean, I could buy a ticket tomorrow and prove that it's real.
Well, then, but you have no good reason to think it's real yet.
I mean,
Right.
I have every good reason to believe it's real.
Why?
Again, geographically, it's on the map.
Yeah, I mean, yeah, and geographically, there are like maps of the solar system, bro.
You have multitudes of eyewitnesses that have been to Australia.
Yeah,
Which
we have
also-
multitudes of
which also
eyewitnesses of people who have been to the moon.
And then just to top it off, right, me at a reasonable price, a very reasonable price, I can go over to Australia and prove
Well,
that it's
have
a real
you?
place.
I mean, you haven't, so I don't know why. Why should we believe you?
But right, I could.
For a
So-
very reasonable
so-
price, you can get a
so-
telescope that can specifically allow
That's
you
a
to
good point,
see.
actually. It's probably
Yeah,
cheaper to
it's
buy a
yourself.
telescope to see the ISS than it is to.
Is to fly to fucking Australia.
So Dr. Blitz, my question to you is, right, same thing with me, how I can buy a plane ticket to go to Australia. Can you go to space? Space is
Wait,
real.
actually, can you prove to me the bottom of the seafloor exists?
That's not how it works. That's not how it works. I ask a question. But you ask me a question.
Okay, so you have to go to the bottom?
No. You ask me a question.
Yeah,
I
go to the
respond
bottom then, please.
No. I'll respond to your question. You ask me a question. Now I'm asking a question to Dr. Blitz now. So Uno reverse. So can you buy a ticket to space right now? Right now, this moment.
I could if I had enough money. Yeah, Blue Origin sells tickets.
had
Yes.
I don't have enough
If
money.
I had
I'm
control of the United States
postdoc.
government.
How much does it cost to go to space?
Like $100,000 or something.
100 grand. All right.
If you give me $100,000, I'll go.
So you see how me going to Australia, right? I could prove that easily at a reasonable.
You could buy a
price.
telescope for the same price as going to Australia,
Again.
and you could see the ISS yourself.
Again.
Someone said it's about 240K. That's
Okay,
wild.
240K, 100K, same
So-
difference basically.
240K to buy a ticket to space.
Yep. How much
And-
money
and
do you think it
that's-
costs to go to the bottom of the seafloor?
No, hold on. So
Someone said
it's
sending now.
240 to buy a ticket to space, right? And isn't there requirements on top of buying the ticket as well?
Nope. There was a really, really old and fat guy who went.
Okay. That's great. So, what makes you think, right, at 240K, the individuals that are buying these tickets at these prices are not, let's say,
If it was 50K, would you believe them?
50K?
Yeah.
Oh, yeah, I probably would, to be honest.
If it was 100K, would you believe them?
100K, not necessarily. Even that seems too high for a ticket. Way too high.
I'm sorry that it's too expensive for your personal views. Point is we can see space
hold on,
with like telescopes. We can see space with telescopes. We can see satellites.
Bro,
so why don't you just buy a telescope, bro?
See,
bro,
and this is how
just buy a telescope.
And see, this is how they gaslight us, right? Because realistically,
nobody's gaslighting you.
No average male, no average female, who lives in a modern house, who's living an average income, is buying a 240K price ticket to for.
You're right. They're buying telescopes instead.
Again, that isn't enough.
$1,000 will get you a.
The average person isn't taking just some random trip to Australia too.
What I'm saying
or
is
the bottom of the seafloor.
What I'm saying is you can control a narrative when it comes to a small scale. If you have millionaires, right, wanting to go to space, NASA could easily be like to them, hey, here's...
Wait a minute, but why do you need to go there to know it's real? You can just use a telescope, bro.
Again, that isn't enough. Let's say if you wanted to go to the moon...
If you can see the space station with a telescope, why is that not enough?
That's you can't even... The thing is, right, again, the videos that you shown, that wasn't even...
You can buy a telescope and you can see it yourself.
Let's put that...
For less than the cost to get to Australia.
Even if I saw a telescope, I would assume it's hooked up to a balloon regardless, so it doesn't even...
Well, where's the balloon? I didn't see any balloons.
Well, how much can a satellite detect? Well, clearly not enough, since even with the images that you shown, the videos that you shown.
Hold on, I kind of want to press this point. So, like the bottom of the sea floor, right? Have you been there?
I haven't been at the bottom of the sea floor, no.
Do you believe it exists?
Certainly.
Why so?
When we say the bottom, I believe, again, I believe in the firmament. I believe there is a barrier at the bottom of the sea that's made of the same material that covers the earth, the dome. So
so how do you know that's true?
Well, I can't prove it. I haven't been at the bottom. I haven't been at the bottom of the sea.
Why do you think? Have you ever been to the firmament?
So you don't know that the bottom of the sea exists?
Have I been to the firmament?
Amy, I appreciate the $2. Thank you so much.
No, I haven't been there, but I believe it's there.
Why?
Not only can I observe from everything I've seen, evidence, videos of people faking space flight, faking the moon landing and everything. All these things lead me to conclude that.
But you don't have proof. You've never seen it yourself.
Well, I believe in the Bible. I believe in what the Bible says, so I don't need to see it to believe it. But
so how did I know that's true? I mean, that was going to be the case. Most scholars disagree with you on your interpretation of the Bible.
Elaborate.
Yeah, most biblical scholars will not say that the earth is flat.
Well, I mean, you have a lot of Christians that believe in a round earth, so I don't disagree with you there.
Almost every Christian believes in the round earth.
Well, again, regardless, you can still... I believe the whole world is being indoctrinated. It's not like believing... what's it called?
The whole world's indoctrinated. Does that include you?
I mean, I don't believe in globe earth. I don't believe there's no firmament. So
you're not indoctrinated because you agree with yourself? Like what?
No, but I agree with I agree with what the Bible says.
Yeah, so Bible is not indoctrination, but science is?
The thing is, right, you guys don't even... If you could truly fathom, right, what it would mean for the world if there was a dome, you would understand why they're doing so much to hide the fact that there is a dome.
Who's they?
Who do you mean, who's they?
I've done data analysis myself that proves the Earth is a sphere.
Again, you're asking
who paid me to do that?
No, I'm not. Again, I'm talking about the people.
George Soros.
I'm talking about the people at the top.
No, I've done the data analysis for an experiment conducted on TikTok. I collaborated with somebody who collected data. I ran the data analysis, and it proved that the Earth was a sphere.
Have you heard the saying a theory can only go so far, right?
I'm not talking about a theory. I'm just talking about data analysis.
Again, still theory.
I personally did it.
It's still theory.
Data analysis is not theory.
Listen, bro,
that's not what theory means.
Listen, the funny thing is, right, you can come up with as much data analysis and conductions and experiments, but for you to truly know the truth, you would need to go up to space, okay?
No,
so that doesn't mean anything. It's just, so again,
like for example, Nardu, let me give you an example. You know radar guns, like they can clock like how fast you're going.
Sure.
You don't have to be on the thing that's moving to figure out how fast it's going, because you can use data, right, to figure out how fast the thing is moving when you point your radar gun at it.
Bro, but the thing is, you're using data, right? If you're using falsified, if you base everything on what you've been told, what I believe as falsified,
I didn't
lies,
base everything on what we've been told. I just looked at the data that I was presented,
but
and
again,
then
you would have,
did trigonometry.
Again, so with those falsified lies, you would have falsified truth. So you saying that you
how is the data false? Did you know that the data was actually collected by a flat earther?
Again,
he wasn't actually a flat earther.
You're not getting the point though. It's like, sure, Dr. Blitz, you've done these experiments and you've conducted the math test, sure, but you haven't been to space yourself.
It doesn't matter. We can figure out the shape of the Earth without going to space.
The thing is, that is what matters, is the understanding.
Yeah, I'm gonna ask you again, yo, dude, have you believe the bottom of the floor exists? And you've never been there.
Again, realistically,
do you know the bottom of the floor exists?
Again,
bottom of the ocean.
Yeah, I believe the bottom of the ocean exists. Yes.
Do you know?
Do you know?
Yeah.
Have you been there?
I don't need to be there to know.
Okay, so the same thing with me. Simple.
Right. So you agree that you don't have to have gone somewhere to know that it has certain properties.
Did he just realize what he just did?
He did.
He just conceded the point.
What do you mean? How did I concede?
Oh my.
Yeah, you don't have to go somewhere to know that it exists.
Okay.
Or to know certain properties of the thing. So you don't have to go to space.
He
to know
ran right into the point without realizing.
The problem is, right, no commoner.
I'm a commoner. I ran the data analysis on the data personally myself.
I'm saying no commoner has been to space. Your average male and female.
Well, so to be fair, that's
that's not true, because like people who are astronauts are necessarily
they're just like normies. They're just normies who got good grades and are smart.
Bro, astronauts are just paid actors, bro. I'm talking about the average human being, okay?
They were average before they became astronauts.
No, again, astronauts, paid actors, bro. I'm talking about me and you.
Do you have proof of that?
Us regulars, okay?
Do you have proof of that?
I mean, I can't prove it necessarily, but you can't.
Okay, so you have no evidence.
Again, how could you disprove it?
We could just ask them.
You could just take their word for it, right? That's
well,
proof.
Who else are we supposed to trust?
Well, couldn't you just say that I'm a paid actor, and then that's just like an unfalsifiable claim?
Actually, Nardo,
right?
You're
because
a paid actor.
I would tell you I'm clearly not a paid actor.
Bro, there's literal
I'm not a paid actor,
evidence. There's literal evidence of people going up to astronauts, telling them to put their hand on the Bible if they've truly been to the moon, and they refuse to do it. So
do you understand that? Like again, as it relates to some random person coming up to me, I'm not going to put my hand on the Bible for any claim.
I mean, it would.
What if he wasn't religious?
Yeah, like if they're not religious, why would they do that? Like, if someone came up to you and brought the Quran and said, "Put your hand on the Quran," right?
And swear to Allah that you're
like you wouldn't do it, right?
The thing is though,
you wouldn't do it, right?
Well, if someone told me to put my hand on the Bible, right?
No, if someone told you to put your hand on the Quran and say you swear to Allah, right? Would you do it?
I'm not Muslim though, so why would I do that?
Quite fucking exactly the point we were making.
No, because the astronauts that they were going up to were claimed to be Christians. So that's
which astronaut was it?
I don't know a specific name.
So you don't know that they claimed to be Christians because you don't even know who it was.
I could easily, if you really wanted me to, I could go get my laptop and prove that to be true in it. But
so let's say that somebody is being harassed on a daily basis by flat earthers, demanding, interrupting his daily life. He's hanging out with his family, going shopping. Some random guy tricks him, says, "Hey, do you want to talk? I'm doing a documentary. Do you want to talk about your thing?" And then he pulls out a Bible and says, "Do you swear on the Bible that you went to?" Like, it's kind of annoying, isn't it?
I mean, it wouldn't. It would take like 30 seconds to just say yeah.
But maybe he's been harassed by people like you for the last 50 years of his life, and he's kind of sick of it.
Well, if he was sick and tired of being harassed, then why would he not just get it over and done with just once? So then he would stop the harassment.
Wait, you understand the same thing could be said about people like Justin Bieber, who have paparazzi around them like all the time, right? And which get annoyed with the paparazzi around them. Do you think that's legitimate?
I mean, again, that's
For what it's worth, there are astronauts who have sworn on the Bible that they went to the moon. So I don't see what your point is. You would just say that they're lying, honestly.
Listen, my whole
Yeah,
thing
so
is,
it's like any point he makes, it's just like never gonna ever change.
the thing is, why doesn't NASA, right, just debunk this whole thing, right? Get a bunch of flat earthers and say, you know what, guys, fair enough. You guys want to see space? You guys think it's fake? Sure, let's bring you up here. Let's put this to rest.
Why would they
Haven't
bring
done
up people?
experiments already like here that like prove to flat earthers that that's not the case?
Keep in mind, flat earthers don't know the slightest thing about physics, engineering, mechanics, any piloting. Flat earthers know nothing about any of that. Why would they risk bringing them up into space?
I mean,
they would die.
It would be irrefutable proof for them.
They would die. Other flat earthers would just say, "Oh, they killed them."
So you're saying that they would die now? What do you mean?
Yeah, because flat earthers don't know how to pilot, don't know how physics works, don't know how orbital rendezvous work. They would unalive. They would cease to be alive.
I'm saying, why doesn't NASA, right, bring these people on one of their spaceships?
I think he means
right?
like bring them up the same way they brought up like the Bezos and the other billionaires.
Yeah, and show these individuals space and just
look,
put the whole.
If that happened, you would just call the flat
promote
earther
political
that went
policy
up.
to do that.
Say again?
Promote political policy to do that. Get
He's
enough
British.
people to care about it.
Their opinions don't matter.
Well, realistically, though, that will not happen. Okay.
Well,
and
here's the thing. Let's say it did happen. You would just call them a shill. You would just You would just call them a shill.
I mean, it hasn't happened, so you can't assume what I'd say.
Yes, I can assume what you'd say because I know how you think about these kinds of things.
If you
Anything
have
that
someone-
disagrees with your cognitive bias, you call fake or you call a shill.
I think you are a paid actor.
I mean, for what?
Do you want to watch a video of Apollo 17's Eugene Cernan swearing on the Bible that he went to the moon?
Bro, the thing is,
it's fake, right? Like he's lying.
He's lying.
Again, I don't even see, even if they did swear on the Bible, right? It wouldn't.
So then why'd you bring it up in the first place?
Like I was just saying, you wanted me to go off words that they've said, and I was just showing you, like, bro, some of these astronauts have also refused to put their hand in the Bible. That's why I was giving that reference. But anyways,
okay, what about the other ones that have?
As I was saying, it still wouldn't mean anything to me, regardless.
So then why was the point even relevant?
Because I would just say, because he was, again,
only the fact that they didn't do it, right, is relevant, not that they did.
I would just, again, he was talking about
That's
words.
called confirmation bias, my guy.
He was saying, just go ahead and ask them. And I was just giving a reference, like, bro, some of these astronauts have...
Yeah, and so when they did ask him, when they asked Gene Cernan, who was the last man to walk on the moon, he swore on the Bible that he walked on the moon.
That doesn't...
It doesn't prove anything, right? It doesn't prove anything.
No,
of course it doesn't. Look, okay, so here's the thing. If I could give you an experiment that could prove gravity is real, would you believe it?
No.
Is there anything... Okay, let me ask a more broad question. Can you think of a single piece of evidence that you could identify yourself that doesn't involve going to space that would make you not believe the Earth is flat?
Yeah, straight. When I look to the sky, when I look up, right, observation, the Earth is not spinning at 1,000 miles per hour.
No, sorry, maybe you misunderstood. I asked you a question, namely, what piece of evidence would convince you that the Earth is not flat without going to space? Is there any piece of evidence that would convince you?
I mean, I've been on a plane before.
That's not an answer to the question. Is there any piece of evidence? What would you have to see that is consistent with a globe model that would convince you that the Earth is a sphere?
I just told you, me going on a plane and me observing the Earth being flat is
great. Hold on, I got something for you. I got something for you then.
If you're going to pull up something with a fisheye lens, that's
it's not with a fisheye lens, I promise.
Okay, sure.
All right, everyone, keep tapping that screen. Let's get to 500,000 likes, everyone. Share the live copy link, send it to a few friends, y'all.
Sorry, I have to connect to my computer at home because that's where my reference is. I have all my references at home.
And by the way, to the people thinking I'm slow, it's like, you fail to understand. You're on a side of a coin. You decided to base your whole lives upon. You get one life, okay? You guys decided to live in a lie. I'm not one of those individuals, okay?
You think the Earth is flat?
Yeah, but this is I'm one of the individuals who is
Thinks
choosing
it's a
his life.
pancake. Thinks
get
you're
one-
living on a pancake.
The thing is, Parker, right? You've again, you get one life, and you're choosing your life.
This
right?
paper?
You're living a life.
A pancake?
And it's not a pancake, bro. I believe it's I believe it's a dome. All right, I believe it's a dome.
It's a dome, like so a frisbee.
Not like have you seen a snow globe?
Okay. You think we live in a snow globe?
Is it this one?
Not literally in a snow globe, but
Are we like
no? It's not that
Satan
paper.
snow globe?
no, we got snow globe.
How do you know we're not Satan's snow globe?
How
How do you know you're not being lied to?
Again, where are you going with this?
How do you know you're not being lied to?
I mean, I have faith. That's my.
I have faith. Trust me, bro, please.
I mean, I could be. I'm not gonna rule out that possibility. I could be, but I have faith and I believe without a doubt. So
Here we go. Found it. The paper is called "Visualizing or Visually Discerning the Curvature of the Earth." Let me flip around my camera. I might actually have to go pull up the actual paper rather than just the abstract. But this is a paper.
Bro, what the hell you want me to do with this?
I'll show you.
Someone said a snow globe.
Let me go to LibGen. By the way, always pay for your academic papers. You should always do that, and definitely not go to LibGen and find them there. 100%, it is unethical to pull up papers from LibGen. Never ever do that.
I'm confused.
Definitely don't do what I'm doing at LibGen. Definitely don't go to Library Genesis. Don't go to scihub.ru to find your academic papers. Anyway, here is this academic paper that I 100% did not view in a illicitly obtained manner. Anyway, so the question is can you actually visually discern the curvature of the Earth? So this guy checked, can you do it? So he went up into a plane. I mean, I can give you the details. So the author has talked to many commercial pilots, blah, blah, blah. That's not relevant. You don't care about talking to people. I'm just looking for the actual part where he describes what he does. Well, here's the picture anyway. So this is a picture from sea level. This is a picture from 35,000 feet. I don't know if you can see this. Sea level, 35,000 feet. So the question is can we actually figure out, by putting this into like photo analysis software, can we actually figure out whether it's curved or not? So here's the same lens, same horizon. By the way, this is the what's it called? The barrel distortion effect that you're talking about. If the horizon is above the middle point, then you'll see it's bending up. If it's below the middle point, you'll see it's bending down. If it's across the middle point, it'll be straight, right? So what you can do is you can horizontally compress, take your full frame. It looks, again, this is barrel distortion, what we're seeing here. And so if you horizontally compress something that's in the middle of the frame, if it's flat, it'll look flat. So we're going to do that with this same photo. Now, this photo here has been horizontally compressed. This is the photo taken from 35,000 feet in an airplane. So what's been done is a straight line has been drawn from the left end of the frame all the way across to the right end of the frame at the horizon. So that's the horizon. That's the horizon. And so let's go to the middle of the frame and look where the horizon is. Sorry, I needed to focus. Focus. That black dot is where the horizon is. You can see a teensy tiny bit of horizon above this black dot. See how the black dot is above the black line? That means that the black dot is higher, that a straight line between the two ends is actually lower than the horizon in the middle of the frame. And lo and behold, if you actually analyze how high the horizon is, using that photograph, using this data here, which is taken from an airplane, center frame. See, by the way, you can look at the inset. You can see the horizon. You can see it like right there. You can see the little horizon that's lower than the actual, or it's higher than the black line. If you look at the inset, you actually find that surprisingly, the radius of the Earth is exactly as expected. Like he literally just took a picture from a plane's window, put it into photo analyzing software, and he found, oh look, the horizon is higher than a straight line, so it's curved.
So
like look how it's higher. See where the black dot is. The black dot's where the horizon is. The black line is the straight line. Why does it curve?
Okay, so examining what you've just shown me, right?
Mm-hmm.
That isn't enough observational.
Of course,
evidence.
it's not. Point is that you can see
Bro.
it from a plane.
Bro,
It's just not
Just take a
enough.
picture.
you sure, bro? That's not even to me. That still looks flat, so I'm confused.
Well,
on why.
so why is it that you can see the gap between the let me make it bigger.
No,
You can see that there's a dark spot that goes across here, right? And then there's the black line, the straight black line. Thank you. You can see that there's a dark line here, and then there's the sky up top, and then there's the straight black line. That's where the horizon is, not there.
Is that the horizon from his observation?
Yeah, it's from the photograph.
Okay, so that's not. So does he have an accurate? Are we talking about a so-called global accurate representation?
This is from sea level.
Yeah, so
This is from 35,000 feet, and we see that there is a slight bulge.
So the thing is, right? That isn't nowhere near enough, like,
This is
observation.
it turns out this is exactly how much curvature you would expect to see. He does
Is
the
that
math.
is that the highest someone can go on a plane?
He does the math, and it actually is precisely how high you would expect it to be. This line here would tell you roughly how roughly what your elevation is, h being. So if you count these, so h is 1 mile above sea level. So if you count the lines, he's basically 35,000 feet, which is just under 7 miles.
Is that the highest you can go on a plane?
35,000 feet is average height for a passenger jet. Yeah,
Okay, so
that's like most passenger jets will fly at a maximum height of 35,000 feet.
Oh, okay. So if there's over observational evidence of people at those heights showing, but it shows a flat, a more.
Yeah, hold on. Let me show you more pictures. Want to see more pictures?
I mean,
Want to see the very first picture of a high altitude taken from a high altitude balloon? Let's see if I can find it.
So
I have it somewhere. First photograph ever made showing the division between the troposphere and the stratosphere. This picture is from what, 19 something?
looks pretty
1935.
flat,
Hold on. We're not done. We're gonna zoom in. So what's been done here is, again, we're gonna draw a horizontal line between the edge, the left edge where the horizon is, and the right edge where the horizon is. Oh, did you see that bulge? You see that bulge?
bro.
There's the right edge where the horizon is. What's that in the middle? It's a bulge.
Bro, a slight bulge is that's not. You're not even that high.
It's a round Earth, my guy.
Bro, that's not even. You need to be much higher to prove to even.
This is 72,395 feet.
Bro, we're talking about seeing the curvature of the Earth. That
Yeah,
is
this is
nowhere-
curvature. It's not flat.
Bro,
See how it's not flat. See
Bro,
how it's bulged in the center because the
bro,
Earth is round.
Bro, a slight bulge does not. Again, this would.
That's exactly what we would expect to see.
You need to be at a much higher altitude in order to see a.
Well, fortunately,
clear
we're at 72,395 feet, and we see a pretty sizable bulge actually. See, there's the line. That's the horizontal. There's the bulge. So it can't be flat. If it was flat, there wouldn't be a bulge, right?
Bro. Oh my gosh, have you seen?
It's a photograph, my guy. It's just a photograph
It's just
of the
not
curvature of the
enough,
Earth.
dude.
Bro,
It's never enough.
It's like what you're saying is it's like looking at the sea and then seeing a slight bulge.
Seeing a
in the
bulge?
sea.
Yeah, because the Earth is round.
It doesn't like.
This is
prove that.
literally proof. This is photographic evidence.
That is not, bro. You need to be at a much higher altitude to see the curvature.
Wait, but I just showed you the curvature. I just showed you the curvature. This is curvature. This is the curvature. It curves up.
Bro, I'm sorry, but we can. That is poor. What you show me is poor evidence of if you're trying to.
Any photographs I show you taken from space, you'll call fake.
I'm not saying this image is fake. I'm not saying it's fake.
No. Any photograph I show you that's taken from space, you will call fake. So I'm showing you things that were taken from people in balloons, as high up as you can go in a balloon, realistically.
Yeah. So
because it's not as high up, the curvature is not as dramatic, but you can still see the curvature. It's obviously curved up.
No.
Did you just say nuh-uh?
Victoria, thank you for the $10 on Venmo. Thank you so much, Victoria.
Did you just actually say nuh-uh?
Bro, you know what? You
Man
guys
just
can
said nuh-uh.
The thing is, right? You guys can gaslight me as
I'm not. I just showed you a photograph. You're gaslighting me. You're like, that's not actually a photo of curvature, and I'm like, bro, it's literally a photo of curvature.
Bro, you guys can gaslight me as much as you want, right? But realistically, though,
Blitz is a pro gaslighter, pro manipulator, pro Pro narcissist. Seriously,
Bro, if we're being,
that's the explanation. It's not that
if
the
we're
Earth
being
is
realistic, right?
spherical.
If we're being realistic, we don't truly know.
Yeah, we do. I just showed you a picture.
That's again that picture is not enough observational proof of a curvature.
Nothing I could show you
said
would be
that same
observational
thing
proof.
on broken record for like the past 30 minutes. He said that's just not enough. I think Blitz has shown you like 10, 15 things, dude. This is crazy.
Let's be realistic now. The only way that we'll truly know, I'm talking truly know, is when commercial space travel becomes available for the world. Okay.
Here's another photograph. Do you want another photograph?
Again, photographs. It won't help your case.
It's a photograph.
Yeah, so the only way he thinks it can be confirmed is if someone literally sends him to space.
A photograph from space.
There's also literally video and streaming of footage of the Earth from the ISS.
But let's show the photo they took of the moon, the Earth from the moon.
What photo of the Earth from the moon?
The Earth from the moon.
Here's the live feed from the ISS, by the way.
No. Okay, so show the photo.
Wait. What is this? What is this that I'm watching right now?
Why are you showing me? I'm confused.
That's a picture. That's a distorted picture, by the way. That has fisheye lens. But this is a 24-hour live stream, so
you just said it has fish. It has fisheye lens. Okay,
that picture does. This does not. What we're seeing, we're just here. The camera's just pointed down. We're just seeing the. Hold on, let me go back to this. Go back to a streaming part. Here, we're just seeing the ISS just going over the Earth.
Bro, that could be. I don't believe anything from NASA. All right, so that's not.
Okay, so there's no evidence that I could provide you that you would accept.
Bro, the only truth, again, for us as the people, right? We can believe anything the government tells us, all right, sure. But for us to truly know something.
Well, I can also do experiments. Why don't you like experiments?
Small scale experiments are still not. Again, we need commercial space travel needs to be a thing for us to confirm.
Dude, he's
why?
Dude, okay. I think this guy's just a broken record.
I'm being reasonable here.
But
no, you're not.
Hold on. You don't hold that same standard of evidence for the bottom of the ocean.
How could we go to the bottom of the ocean?
You could take a submarine.
Wait, by the way, if we can't know, why aren't you agnostic?
Say again?
Why aren't you
because
agnostic
he believes in the
then? If we don't know, why aren't you agnostic?
That doesn't. What do you mean? Why am I not agnostic? Why should I be agnostic?
Because you don't know. That's what agnostic means.
No, because my evidence of a God is creation. That's what I see as evidence.
So you're only willing to accept if someone sends you to space. So what are you doing on a debate platform?
Say again?
What are you doing on a debate platform?
What do you mean?
Like, if you're not willing to engage with any point, or like, what's the point of debating it?
I've literally engaged for the past how long?
Well,
no, you're not.
Have you though? You just said
engage
it's
with
fake.
any evidence. Yeah.
You just said it's fake. Every single thing I showed you,
Bro,
it's just fake, or it's not enough.
All right, let's conclude this. Before I go. In conclusion,
okay.
What you've shown me, right? You may see that as viable evidence, as that's what you may see. But for me,
I can give you a whole bunch of other evidence too, but I don't think you'll care.
What I can conclude is, like, look, at the end of the day, we only truly know when commercial space travel is available for the whole world. Okay, we'll only truly
It's
know.
literally a broken record. I can't. Yo, take a shot every single time he says that, chat. You'll literally be in the hospital at the very end of this.
Yeah, but this is the thing, though. Commercial space travel will never be available. They'll never make it available for the world.
That's a prediction. Do you have evidence for that?
I'm just being straight.
You're just saying it, right?
Yeah, straight up.
Okay, so I shouldn't believe you though.
I mean, again, if I'm wrong, then I'm wrong. If they somehow make commercial space travel available for everyone, then I will concede. If I somehow buy a ticket to space, if it's at, let's say a £1,000 ticket to space, right? That's available globally for me as well. I could go up to space and see a globe Earth, then boom, that's flat Earth finished, right? Sure, but realistically, that's the only time when we'll truly know if the Earth is round or flat. If we're being realistic.
Okay, all right, bro. We're gonna go on to the next person. Appreciate you coming up though.
No worries.
All right, let's go on to the next individual. Only send a guest request if you think that the Earth is flat, y'all. If you want to support me, Venmo, Cash App in the bio, as well as you can gift Blitz, everyone. Make sure to do so if you do want to support the education, y'all. Keep tapping that screen, everyone. Let's run it up to 500,000 likes, y'all. 500,000 likes, y'all. Yo, what's up? How old are you?
Can I steal something? I just want 4,000 people to meet my lovely wife.
Sorry.
He added me to vote. Bro, what the fuck?
Anyway, all right. She's going to to the store. I just wanted everybody to meet her because she's great.
Yeah, all right, Declan, how old are you? Okay, this person's not even here. Only send a guest request if you disagree. We are just looking for some debates. Only send a guest request if you think that the Earth is flat, y'all.
She's so embarrassed.
Yo, what's up? How old are you?
I'm 50.
For sure. Do you think the Earth is flat?
It's debatable.
Do you think it's flat?
It's debatable. I mean,
do you think it's flat?
Actually, I do.
Okay, why?
I do think it's flat. Because I have questions that really don't have accurate answers, such as, like for instance, it's how big is the Earth?
About 4,000 miles in radius.
4,000 miles, correct?
Mm-hmm. About 3,957 or something like that, as measured from the equator.
Rounded off, 4,000, right?
Yep.
And how much curvature is there? When
the radius of curvature is 4,000 miles.
Okay, so it's been said that the curvature at a certain distance disappears.
What?
As far the horizon.
What do you mean the curvature disappears? I don't know what that means.
I'm sorry, the horizon. When a vessel takes off and it disappears, how far does it have to be in order for it to disappear?
In order for it to pass below the horizon, it depends on the observer's height. It depends on it depends on the observer's height and the height of the thing that's disappearing below the horizon, right?
Okay.
So if you were at around 6 feet tall
at the beach,
so if you're at around 6 feet tall, you will see the bottom of things start to disappear around 3 miles out. Around 3 miles out, I say. And that's neglecting atmospheric conditions, of course. Atmospheric conditions can change things plus or minus 10% or whatever.
Okay. Another question, which has to do with obviously the first man landing on the moon. Who took the photograph or the footage?
For the landing or for him stepping off?
For stepping off.
There was a camera that was on an arm that was on the thing, and it deployed, turned around, and then took a selfie.
Okay. All right.
Are you a Glober now?
It's debatable. Just had a few questions, that's all.
Okay, for sure. All right, let's go to the next individual. Only send a guest request if you think the Earth is flat, y'all. Keep tapping that screen. Let's run it to 500,000 likes, y'all. Yo, what's up? How old are you? Hello?
Hello?
Yeah, how old are you?
I'm 22.
Do you think that the Earth is flat?
100%.
Why so?
See, first of all, I've been on a plane a few times, and it just doesn't work, right? Like, the math just doesn't check out, and it looks pretty flat to me.
What math?
Like the 8 inches per mile, for example, that just doesn't seem pretty good. It doesn't
What doesn't seem good about it?
I've done some calculations in my head, and it just seems really flat, so...
Can you elaborate on these calculations?
I don't have it right in front of me, but just
I thought you did them in your head.
It's been a...
You're a troll. Get out of here.
Yeah. All right.
Yeah, we knew he was trolling. All right, let's go to the next individual. Only send a guest request if you think the Earth is flat. Everyone, keep tapping that screen. Keep sharing the live, y'all. Yo, what's up? How old are you?
72.
Okay. You do sound old enough, though. So do you think the Earth is flat? Oh, he left anyway. Okay.
We still have signal appearing down here, even though it's around the curve. And this is called diffraction. See how there's signal here, even though it's around a curve?
Yeah, I see what you're talking about. But this
that's
thing,
called
this
diffraction.
thing
That's what's happening here.
way different. This one that they have is only a laser beam.
They're talking. It's not a laser beam. It's radar, or it's radio waves rather.
Oh, yeah, you are on the website. Yep, you are on the website.
Yeah.
Okay,
it's a radio wave. So they're talking about it's a straight line this way, but it's not a straight line from the side. It's like this. It's called ground transmission.
I don't know what you mean. Like, how does that? It's still.
So the point is that you can have a radio wave that is obstructed by the curvature, and yet you would still see signal over here, right? Like the signal bends around curves.
Why would it bend around a curve?
It's called diffraction. That's what I'm showing you. This is a simulation of the exact same thing that's happening.
Okay, we can drop this for now. But listen, all right, if that's the case, then why is it that everything that you experience is where it's always got to be the opposite? Because it seems like everything is the opposite from what we experience. Like, if you was never told that the Earth was round, you would naturally think I was crazy if you was never taught that as a kid.
I would do an experiment and figure it out.
No, you would never have thought you was spinning all these directions because we don't experience that. We don't experience like we're spinning. We don't experience.
Yeah, but we do experience sunsets, right? And sunsets can't really be explained on a flat Earth. So it would make me question it, and I'd be like, well, how does a sunset work? And then I would go and look into it, and I'd be like, well, it only works on a globe.
You guys, I know what your argument is about this, but it's not.
Do you? Because I came up with it today.
The sunset, you can make everything look like it's going over a curve.
So let me ask you this. On a flat Earth model, flat Earth, sun moving further away, can you use that to calculate the duration of a sunset from Ecuador on September 21st?
I mean, I don't know specifically.
Well, so I'll tell you, it is impossible. There is no way to determine the length of a sunset using a flat Earth model in Ecuador on September 21st. There's no way to do that. It is impossible.
How do you know there's no way to do it?
Because I've tried to do it. It doesn't work. However, on the other hand, on a globe Earth model, you can predict it, and not only can you make a prediction, it's correct.
So I never heard of this one before.
I know, because I thought of it today.
All right, well, I'm pretty sure that there could always be an explanation for it. I mean, I don't know.
Unfortunately, there isn't. I've tried. There is no way to work out the duration of a sunset from a flat Earth model.
What do you mean by duration of a sunset?
You know how long it takes for the sun to go like right when the sun touches the horizon to when it dips to when you can no longer see it? That's what I mean by the duration of the sunset.
And you can do that on a globe for sure.
Yep. From the equator, which is where Ecuador is. I'm going to walk you through it. From the equator, which is where Ecuador is, on September 21st, that's the equinox. So that's precisely when the sun goes directly overhead, sets directly east and west, right? So on the globe Earth model, the Earth rotates 15 degrees per hour. That's 1 degree every 4 minutes. Now, the Earth, or the sun, is half a degree in size. And so all you need to do is figure out how much, on a globe Earth model, all you would need to do is to figure out how much would it take for the Earth to rotate half a degree. Now, if it's 4 degrees every, sorry, let me make sure I get my math right. It's 1 minute for every, it's 4 minutes for every 1 degree. So in order to rotate half a degree, it's 2 minutes. And so what you can go do is you can go to Ecuador on September 21st or April 21st, both work. Both equinoxes work. And you can just get out a stopwatch, time how long it takes for the sun to touch the water and for it to disappear below the water. It'll take almost exactly 2 minutes.
Okay, so it takes
Which is exactly in line with the globe prediction. But you will never be able to make a prediction using the flat Earth model that gives the same answer, ever.
Okay, but then again, if the flat Earth model does not have a defined of a size, for one thing, we don't have a specific size of how big the Earth is to be able to calculate.
It doesn't matter. There is no size of the Earth that you can use to figure out that the sun will set in exactly 2 minutes on September 21st in Ecuador. There's no size of the Earth that will make that work for a flat Earth.
And
I've done the math on this. It just doesn't check out.
So, but you're trying to tell me that the math checks out for the globe then?
Yeah, I just did it for you. I just walked you through the math. I can do it again if you want.
Now I'm gonna have to think about this one for a little bit, because I'm pretty sure there's an answer to it. And I mean, I have a whole lot of reasons, but I'm not going to get into them right now because I'm going to really think about what you just said for a little bit and try to figure this out. But I appreciate it, bro. I'm going to get off here.
All right, appreciate you coming up. All right, let's go on to the next individual. Only send a guest request if you disagree. If you want to support us, Venmo, Cash App in the bio, as well as you can gift Blitz here on the live. We're going to go to the next individual. Keep tapping that screen. Let's run it to 500,000 likes as well. Share the live, everyone. Let's try to get it to 1,000 shares as well. Yo, what's up? How old are you? Hello?
Hello, can you hear me?
Yeah. How do you think that the Earth is flat?
Yeah, can you hear me?
Yeah, why do you think the Earth is flat?
Okay, I'm not hearing you very well, but okay, I'm not sure either way, but I'm actually going to ask Dr. Blitz because he might be able to answer two questions for me. One, well, actually they're connected. Okay. As an ex-Navy man, I passed through the Suez Canal and many canals, and the Suez Canal is what we call an open canal. It doesn't have any locking system in the canal. So in other words, you can go straight through and steam the ship from Port Said to Suez without having a locking system in rising or lowering of the water levels. Okay?
Sure.
So the Suez Canal is like 120 miles, which is like about 170 kilometers long.
Okay.
My issue always with this was in the ratio of a curvature over that length of distance, why is the water not flowing like a tidal bore south or north? Why does it lie
Why
level?
would it flow south or north?
Why does it lie level? Why is it level? In taking into consideration that it's 120 miles long.
Why would it flow on a globe?
Well, what I'm trying to say to you, if that length has a curvature,
yeah,
it surely has to flow in one direction or both directions away from, say, the center of the curve outwards.
Why? Gravity's pulling down in all directions. It's not pushing. It's not pulling to the side or anything. It's pulling down.
Well, that would mean that if gravity pulls it down somewhere in the center, you have very little water, and at the ends at Suez and Port Said, you'd have deeper water.
Why?
Because it has to pull down according to you with the curvature.
It pulls down in all directions. It pulls down towards the center of the Earth. It doesn't matter how long it is. It's always pointing the same direction towards the center.
Okay. Well, leaving that aside, and you can keep sticking with the locking system. Okay.
Mm-hmm.
So you have the Panama Canal and the Manchester Ship Canal.
Yeah,
and
sure.
It's the very same system, and the Manchester Ship Canal is very long. Mm-hmm. Except for they have to have 5, 6, 7 locking systems where you have to bring in the ship and rise the water to bring it up to the level that they need as you go up.
Because different seas, different lakes, different oceans are different levels.
And the same in Panama. My question really is, what's happening in Suez and happening in the Panama Canal, Manchester Ship Canal, it's not lining up with the it wouldn't be lining up with they can't be both doing the same thing, because that's the whole idea of having a locking system in the first place, is to bring the ships to different levels, whether it be lower or higher.
That's not why. That's not why Panama has locks. Panama has locks because it goes over hills.
Okay, Manchester Ship Canal.
I don't know if there's hills in the way. I can Google it though.
It's one of the flattest areas of the United Kingdom. Just as the Suez is, but the Suez is open. It has no canal system. It's wide open from Port Said to the Suez.
Right. So the Manchester Ship Canal features several locks, sluices, and weirs that allow ships to move from sea level in the Irish Sea up to 60 feet above sea level at the terminal docks in the city of Manchester, located 40 miles inland. It's because Manchester is 40 miles away from sea level, higher up. It's 60 feet above sea level. That's why they need locks, because they have to go up. They have to go uphill 60 feet.
Okay.
Because Manchester is not at sea level.
So okay, I'm not disagreeing. I'm actually trying to get some bearings myself on this, because it is something that I could actually never figure out. Because the Suez is very unusual in the sense that it's so long, and it, like at 120 miles long, it's an open system, and like I said, the curvature. Now, if you're explaining to me that that's what the gravity is pulling it down at both, are you saying at both ends, i.e. the Suez at one end,
everywhere.
Port Said the other end?
And in the middle and 3/4 along the way, it's pulling it down everywhere. Down is the direction of gravity, not sideways.
So, again, that doesn't kind of line up with tidal movements with me.
Tidal movements aren't due to Earth's gravity.
But you have tidal movements going through the Suez Canal.
Sure. That's because
it's
of the
open,
tides.
it's not
Tides
on the
are
canal
from
system.
Yeah, that's fine. Tides can flow through open bodies of water because of the moon and the sun, which are the cause of the tides.
Yes.
Doesn't have to do with Earth's gravity. I'm not sure why tides are relevant here, though.
Well, tides flood and ebb.
Yeah.
So, if you say it, are you saying that gravity doesn't affect the tidal movements in a flow in the net?
No, it's just not the gravity of the Earth. It's the gravity of the moon and the sun.
But it affects all water, all movement of water.
Well, it affects movement of large bodies of water, and because the Suez Canal doesn't have any locks in it, as you said, it is effectively connected to two very large bodies of water. Is it the Arabian Sea on the south end,
Sea.
and then it's the Red Sea on the south end, and the Mediterranean Sea on the north end, which are both very large bodies of water, which, because they're so large, they're going to have tides. Okay,
well, yeah, well, you've answered it in certain ways, but it's still not resonating right with me. But look at, just one more short question there. I guess after being in the Navy for 20 years, so spending a lot of time on the bridge of ships, you work off radar screens and visually, both day and night, and you have to obviously give your commands to the chief officer or the captain whenever you spot a vessel, and
Sure.
you pass on those commandments to the captain at what distance it is away and what movement it is, whether it be to port or starboard or left or right, as you can understand.
Sure.
And in 20 years, and in very, very long ranges of even visually from my eye without, and matching up with what I would see in the screen of a radar, I have never, and this is probably the biggest fool one for me, I have never ever encountered any curvature of any form whatsoever.
You haven't seen it? Is that your claim?
Yes. And
with your own two eyes? I'm sorry you haven't seen it. That doesn't mean it's not there.
Well, it doesn't mean it's not there, but I mean, when you're talking about certain figures about certain heights off the ground and how far away the vessel is.
Yeah, how far can a ship's radar go, roughly?
Well, radars can go a couple of 100 miles, but you won't see that visually.
Sorry, that doesn't seem true. I'm on boatus.com, and it looks like, large ships have radars that go 12 nautical miles.
No. There's many different types of radars that can go. You'll only have it as a tiny blip, but obviously as it gets closer, it becomes a bigger blip on the screen. But what you will see
the advertised
radar,
maximum radar distances
with the
are.
naked eye.
Sorry, one more time.
what you will see in the radar, you won't always see with the naked eye until a certain time.
Yeah, sure, because it's further away than you can see. That's fine.
Like I said, it's not even really a question. It was more like a statement that I've never ever seen any form of curvature whatsoever. And
okay, I mean, have you ever seen air?
Sorry?
Have you ever seen air?
Air?
Yeah, like the stuff we breathe. All this stuff that's around me. Have you ever seen it?
No, but I see the trees blowing.
Yeah, so you see the effects of air, but you don't see the air itself, right?
So I know it's there.
Right. So you can see the effects of curvature without seeing the curvature itself. For example, you can see things dipping below the horizon like sunsets. You can see the lengths of shadows change in ways that are only consistent with a curved Earth. You can see the angles of triangles made in large straight lines.
The length of shadows, is that what you're saying?
Yeah, the lengths of shadows. That's one common proof that's used to give the shape of the Earth. Yeah, okay, it's the famous Eratosthenes experiment, but you'd have to have a little bit of trigonometry to.
Okay, well, that's definitely something I'll need to look into. I haven't heard that before. The length of the shadows. No, listen. Thank you. That was interesting. You've given me something to think about there as well, and so thanks very much, guys.
I appreciate you coming up. Thank you so much. All right, we're gonna go into the next person. Only send a guest request. If you disagree, keep tapping that screen, everyone. We're close to 500,000 likes, everyone. Keep sharing the live as well, everyone. Yo, what's up? How old are you? Oh, let's get to the next person real quick. Again, please, everyone, only send a guest request if you think the Earth is flat, y'all. Yo, what's up? How old are you?
Oh, me?
Yeah.
Oh, sure. I'm sorry. I'm 45.
For sure. Do you think the Earth is flat?
I do not.
All right, we are just looking for people who disagree, but I appreciate you coming up. Thank you so much. Only send a guest request if you do disagree. We are simply just looking for some debates, y'all. Keep tapping that screen, y'all. All right. Okay, it's not accepting people now. Some people were asking for Jim. Not again.
Is he in the
No, Jim's not in the crust. Yeah, what's up? How old are you?
23.
For sure. Do you think the Earth is flat?
Yeah, I do.
Why
think
so?
it's flat. All right, so 1 second. One live. So yeah, okay. So give me a second. All right, let's go outside. All right. So the reason why I believe the Earth is flat is because of the observation based on my experiments.
Hey, there's a lot of static on your microphone. Is there a way
I can't
you
give
can
a lot
fix
of
that?
word.
Okay. We'll give them a second, everyone. I don't know what's going on with they're like shifting into a different dimension right now. So just give it a minute.
I mean, look, if you go past the firmament, that's where you end up.
Yeah, essentially, I think he just crossed the firmament, chat.
Maybe the Van Halen belt too. I don't know.
All right, I think he's not even here anymore. All right, I'm just gonna go to the next person. Everyone, please only send a guest request if you disagree. We are simply just looking for some debates. Only send a guest request if you do disagree, y'all. He just fell off the side of the Earth. What's up? How old are you?
19.
19?
Yeah, December 17th, 2003.
December 17th. That you'd be
20.
Yeah.
I'd be 19.
No, we quite literally can't do math.
He would have turned 20 like a month, just over a month ago.
10 days ago. 10 days ago. Okay, it's not. Or did he say November? Oh, then it would be a month ago, yeah. Only send a guest request if you disagree, y'all. Oh, they said December 17th. So it was only
See, here's the thing with that filter, asking for the age and the year. That'll filter out most flat earthers too, because they're not very good at math.
That's truly unfortunate. Oh my gosh. Yeah, chat, that was brutal. All right, we're going to try to get the next individual up. There's not many people up here, so if you do disagree, if you think that the Earth is flat, send a guest request right now, y'all. Okay, it's really not accepting people, everyone. Buy a calculator. Absolutely, buy a calculator. Okay, it's not accepting people, everyone. I'm trying to get someone up here. Only do some guest requests if you disagree. You haven't seen them pop up?
No, I am seeing them pop up. I'm seeing their profile pic.
Oh, they pop up, but they don't load in. You know what's up? How old are you?
32. Sorry, I don't think about my age.
For sure. Do you think the Earth is flat?
When I came here, yeah, but listening to everybody debate, it's hard to stay there. But now I got questions that I don't know how to answer. So like earlier, somebody had mentioned something about not believing in gravity. I technically don't believe in gravity either. I feel like magnetism can do everything that gravity does, and I feel like we're giving credit to gravity, the things that magnetism are doing, but I don't know how to tell the difference between, like, how do you measure gravity in difference to measuring magnetism? How do you know that, like, oh, this is definitely not magnetism and this is definitely magnetism?
Yeah, so I can help. So first, if it was due to magnetism, if it was magnetism that was holding us to the ground, then we could take a magnet.
Yeah, House of Throff, is there a way you can mute your mic? There's a bit of a feedback in the background.
I'm gonna take my headphones off, see if that helps.
For sure.
Is it better now?
We can still hear the background noise.
Oh shit, I guess not.
You can just mute your mic whenever he speaks. Do you know how to mute your mic? Okay, I'll do it for you. I got you. All right, go for it.
Right.
Oh,
so
it's literally not letting you mute. What the hell?
There we go. Right. So if it were due to magnetism, if it was magnetism that was pulling us down, that means that if we take the north pole of a magnet, it might pull the north pole of a magnet down, but if we flip it around, it would push it up. But we see that magnets can fall down regardless of what direction they're in. As far as testing and distinguishing between magnetic effects and gravitational effects, we can just produce an experiment where you have one very heavy object, say made of lead, which isn't magnetic, it's not paramagnetic, doesn't produce its own magnetic field, and then one very light object, and we can see that the light object is actually pulled towards the very heavy object. And neither of them, like, we can check that neither of them are magnetic, and yet they're still pulled to each other. Why might that be? Well, I mean, it's not magnetism. It seems that it conforms to the law of gravity, so I don't know, man.
All right, here, let me unmute him real quick. So, accept this wait, is there another person that's connected?
What is happening?
Yeah, can you disconnect whoever's the other person connected? Can you please disconnect, please? Yep, please disconnect. Please. No one else can hear you. Please disconnect.
I can hear him.
Yeah, I know. No one else but us can hear him.
Okay.
Yeah, I was able to hear him too.
Yep. Please disconnect, though. All right, go for it, Thoth.
Okay, so I appreciate that. Thank you. Also, I was because damn, I'm sorry. I've been holding on that question so long, and actually, I lost that one. I'm sorry.
Magnetism. That's what we were talking about.
Yeah. I had another question as well, because you actually explained that pretty clear. So to sum it all up, because so I know I understand what you just said. The reason we know that gravity is different than magnetism is one because I'm sorry, I'm bad at repeating things the way I hear it. It's Newton's laws, and the way things stick to each other when the way magnetism works is not the way that things stick to each other due to gravity. So I'm sorry, I'm saying that poorly.
No, you're good. Yeah, so gravity attracts, it seems like the Earth attracts everything, whereas magnetism only attracts opposites. But like we have magnets, like if you have a magnet that's one direction, it'll be attracted to the ground. And if you flip it the other direction, it'll still be attracted to the ground.
Thank you. Frequency resonance. When things resonate certain ways, they like funny things happen, right? So if you vibrated something at the right frequency and another thing at the same frequency, or at a I don't know if it's the same frequency, at a specific frequency, you might be able to pass them through each other, or make them like I don't know, like explode and things like that. So I was wondering, or even
just funny.
Like could vibrational resonance also cause
Hey man, is there a way you can get out of a place with so much background noise?
My bad. Yeah. So
so much better.
I don't know if this is better. Oh yeah, good. I'm glad. Okay, so is there a way that vibrational resonance or like resonant frequencies can cause things to stick to each other or like attract
Not really,
to each other?
no.
Okay. All right. So yeah. So I'm pretty much on your side now. I just needed to know because I thought that like if you can vibrate certain things to a certain frequency, you might be able to get them to stick. And I don't remember why I actually came to that thought, but yeah, helped me clear that up, man. Thank you. I appreciate
All right, man.
that.
Appreciate you coming up. Thank you so much, man.
Thank y'all.
All right, let's go to the next individual. Please only send a guest request if you disagree. We are simply just looking for some debates, y'all. Please only send a guest request if you think that the Earth is flat, y'all.
Oh, I think I may have talked to this guy before.
Yo, what's up? How old are you?
Yo, 32.
Have you talked to Blitz before?
Yeah, I've talked to Blitz.
I think it was a while ago.
Yeah, it's been a cool minute. How y'all been though?
Is it already? Have you already talked about this topic?
No, I haven't been up today yet.
No, I'm obviously not today. I mean, have you and Blitz talked about this?
I think we talked about it a while ago, but I don't even remember the conversation. I just remember the name.
Okay. Yeah. If you don't know any of the content material, whenever, it's fine. Go for it.
All right. The other guy was just talking about gravity versus electro forces, right? I wanted to ask Blitz, what is the force that pretty much keeps like atoms and other things that form bonds at that level? What is the force that keeps them together? Is it more like electrostatics, or is
it's electromagnetism. It's not necessarily electrostatics, although electrostatics can be a good approximation at some levels. Yeah.
Okay, so could it be kind of true that if the more atoms, you know how like if you put two baseballs in space, they'll kind of like pull towards together, right? Like they'll try to. Okay, so is that because of the buildup of atoms? Do they exert a force that pulls them together? Like
it's not because of the electrostatics. No. Because they are not average. They are neutrally charged, so there is no external electric field produced by the conglomeration of atoms that make up the baseball, for example.
But I'm saying, like, I guess what I'm trying to say is the more atoms you have in a single spot, like the denser something is, it generates its own kind of pull towards something in the just out there in space, right? So if that's the case, the bigger something
mass does that, not electrostatics.
Yeah, but mass is due to density, I guess. And
mass is not due to density. Mass is due to how much stuff you have.
You said how much stuff you have?
Mm-hmm. Like how many atoms there are. Doesn't have anything to do with density.
Yeah, and as I was saying before, like atoms create their own kind of force. So what I'm really trying to say is, does that force amplify the bigger something is?
No.
And when does it go from?
It actually gets smaller, because you have more charge cancellation happening.
Charge cancellation?
Yeah. So like when, for example, if you have a sodium ion attracted to a chlorine ion, that's what makes up table salt, sodium chloride. It's because you have a negatively charged thing and a positively charged thing attracting each other. But when they come together, the negative charge cancels with the positive charge, and so that whole unit is not strongly attracted to anything else.
Sounds about right. So you wouldn't relate gravity to anything related to electrostatics or anything?
Yeah, they are distinct phenomena.
Okay. All right, that's the only question I had, man. That's the only time you guys really see me is when I have questions that, just swim around in my head.
You're allowed to ask questions, bro.
Yeah, for sure, man. Appreciate you coming on, bro.
No problem, man.
All right, let's go to the next individual. Only send a guest request if you disagree. We are just looking for some debates. Keep tapping that screen, everyone. Let's try to get to 500,000 likes, y'all. Yo, what's up? How old are you? Hello? All right, let's get to the next individual real quick, y'all. Only do send a guest request if you think that the earth is flat, y'all. Okay, it's not accepting these individuals. Let's try the next. Yo, what's up? How old are you?
18. I was born in 2005.
For sure. Do you think the earth is flat?
No, I don't, but I joined before you said that, and I was like, oh.
Oh, you're good. Don't worry. Appreciate you coming up, though. Only send a guest request if you disagree, y'all. We are simply just looking for some debates, y'all. Yo, what's up? How old are you? Oh, they just left. All right, let's try the next person. Again, everyone, only send a guest request if you do disagree.
The earth is
Yo, what's up? How old are you?
People walk on the ground, and our feet, the bottom of our feet is flat. So the earth got to be flat because the ground is flat.
Wait, are the bottom of your feet flat? Because, bro, you should probably go to an orthopedist, like an orthopedic surgeon or something if your feet are flat.
You can say that, but the bottom of my feet is flat, and I'll be able to walk on ground.
I don't know, bro. This doesn't look super flat.
It looks flat to me.
Okay. Might want to go get your eyes checked then.
For sure, for sure. 2023, class of 2023.
Oh, now I'm feeling old.
Well, I had a lot of young teachers.
What?
Class of 2023.
Bro, what are you
about
saying? Can you give me like an argument that tells us, like, can you explain Oh, he just left. Okay, I was about to ask him to explain sunsets. All right, we're getting the next individual. Only send a guest request if you do disagree, y'all. Yo, what's up? How old are you?
22.
For sure. Do you think the Earth is flat?
Well, to be honest, I just debated in my head on them, but I don't feel like
what?
I just debated in my head on them, but even more, everybody have proof. They have proof that the Earth is round. They have proof that the Earth is flat. But just as they have proof for the both, I don't really know how to differentiate from. Even though there is a way to differentiate, but it's like you're growing up your whole life and you're telling you the Earth wrong. So like automatically you're gonna think for the rest of your life, or until you know better, until you get such knowledge, Oh well, yeah, the Earth may be wrong, it may be flat. Then you read the Bible, and the Bible explains how he made the earth and stuff like that in terms of the firmament and stuff like that. It just
do you believe the Earth is flat? You do?
Yeah, well, yes.
Yeah, you believe the Earth is flat, and you believe that because of the Bible.
Yeah, because I don't.
How do you know the Bible is accurate in making claims?
You see,
like the Earth is flat?
exactly. No, you see that exactly like what I know explain. But then too, I don't wanna question the what if, because the what if is actually very big. It's gigantic. You know what I mean?
Yeah, it's really big.
Liz,
really
thank
big.
you for the $5 on Venmo. Yeah, it's really big. What's your point though?
My point is that, like whenever we do get the real proof that, and we could actually prove it, and we could all see it, then,
yeah,
when I got actually like pee and they could actually carry me to the end of the flicking earth, then.
yeah. So like sunsets, right? Like the sun sets. It goes like this, right?
Yes.
That's proof that the Earth is round.
Yeah.
Oh.
Yeah.
We've all seen it.
Somebody saying Looney Tunes? Really flick.
Oh, so you agree that it's been proven that the Earth is not flat?
Well, it seems like it had too much things to debate, because I believe in God. I believe in the Bible. A lot of things, as you say, I don't know how accurate the Bible could be. People change things in the Bible. It's like you're growing up your mommy telling you you need to brush your teeth every morning, and if you don't brush your teeth, your mouth gonna smell like shit. You know? You understand what I mean? It's a norm.
Sure, but we can all see the sunset.
Yeah. But everybody just questioning everything, and when you hear something, it sounds convincing, and then when you do your own research, it sounds convincing, and then I find like it's too much.
At a certain point, you have to trust yourself, right? At a certain point, you have to trust your ability to understand what's happening, and to understand who's lying to you and who's not, who's making stuff up and who's not. But all I'm saying is the sun sets. It goes like this. So, how does that work on a flat Earth?
Oh boy. I thought I enjoyed the conversation. Right? Everybody have a good night. Merry Christmas. Happy New Year. I go in because I had to go and I cooking something in the kitchen.
All right. Sure. Well, thanks for being here.
Appreciate you.
I'll be listening though. I'll be listening.
All right, let's go to the next individual. Only send a guest request. If you disagree, everyone tap that screen. Let's try to run it up to 500,000 likes. I'm confused, honestly.
That's okay.
Hello.
Yeah, what's up? How old are you?
26.
Do you think the Earth is flat?
Yeah, part of me does, yeah.
What do you mean part of you does?
I mean, yeah, there's a part of me that has done some research and has like
So you don't believe it?
Pardon?
What do you mean by part of you? Like that doesn't really make any sense.
Well, so like some part of me thinks it is a possibility.
Yeah, so what makes you think that? Or sure, what do you mean by possibility?
Well, because there has been evidence shown of NASA lying about quite a few things, and I'm just wondering about their motives on that.
Can I show you something?
Yeah.
One sec. One moment. Come on, work. There we go. All right. See. Oh, God damn it. One sec. Let me do it a different way.
Loading. Just give it a second, everyone. Keep tapping the screen. Let's get to 500,000 likes, y'all. As well, you can gift me and Blitz. You can gift Blitz through TikTok or me through Venmo and Cash App, y'all.
Yeah, so you see that behind me?
Yeah.
It's a globe, yeah?
Yeah.
It's from 1697, long before NASA existed. So it's not just NASA. This isn't a NASA thing, right? This is everybody in history for at least 1,000 years.
Yeah, but we all know that in history they used to think it was flat as well.
It's actually not, I mean, like maybe more, about 2,500 years ago, sure, they did. But even going back as far as Aristotle knew it was round.
Pardon, who's who?
Famous Greek philosopher, natural philosopher guy.
Okay, and he did what, sorry?
He knew it was round. He gave like a list of like 6 proofs that it's round or something like that. One of them was sunsets, others were ships dipping below the horizon. There's I can pull up a list if you want. I don't know how convincing that would be, but suffice it to say that was more than 2
studies that were done after that. So that are like
which
on the internet you can see. So like, was it Operation Fishbowl?
What does that have to do with the shape of the Earth?
Pardon?
What does that have to do with the shape of the Earth?
It has got to do with it. I said like, what about the studies that have been done since then?
Yeah. I'm asking, what does Operation Fishbowl say about the shape of the Earth?
Is it Fishbowl or is it the climb one or?
Operation Fishbowl was about testing high altitude, or was about doing high altitude nuclear tests.
Yeah, which
it doesn't have anything to do with the firmament. They were just testing nuclear weapons at a high altitude.
Why is it called Fishbowl then?
It was just the name of the thing.
It sounds a lot like a firmament.
Fishbowls are spherical, not domes, right?
A dome is half a sphere, spherical. A dome is like sort of...
Not necessarily. It could be parabolic, for example. But I mean, are you just saying that Operation Fishbowl proves it because the name is Fishbowl?
No, not just that.
So then what's the proof?
Well, the proof, like, of the scientific operation they had.
Yeah. What did Operation Fishbowl do that convinced you that it was flat? That convinced you that this means that it has to be flat?
You just paused. We can't hear you right now, by the way. You just paused. We cannot hear you.
Sorry, can you hear?
You're good. Yeah, we hear you now.
Yep.
So I think it has something to do with the ice wall as well. Which,
Operation Fishbowl didn't have anything to do with the ice wall. It was just high altitude nuclear tests. It was conducted. Where was? I can check where it was conducted. It was conducted in
the ice wall from
Johnston
the
Atoll.
high altitude, so they didn't see a wall.
No, they were just detonating nuclear weapons at high altitudes above Johnston Island in Johnston Atoll, which is nowhere near Antarctica.
Okay, so and about the winter and summer solstice, for example.
Yeah.
How would you explain that works in your theory?
The Earth's tilted. Actually, let me just pull up a picture. Because I would normally draw it, but I don't have a pen and I don't have paper right now. So let me just get the right picture. Here we go. Okay. Oh, this is really, really blurry. Let me see if I can find a better picture. So there's exactly a thing I'm looking for. It's not a good one. Okay, well, this will have to do. It at least conveys the idea, even if it's blurry. Let me just scroll down. Here we go. Oh, it's actually not blurry on the original. Right. So, want to make me big, Parker? Right. So here we have the tilt of the Earth. So in the summer, in the northern hemisphere, the Earth is tilted towards the sun. In the winter, it's tilted away. Now, this is really, really high contrast, but you'll have to bear with me. So during the summer, because of the tilt of the Earth, these sun rays are more concentrated in the northern hemisphere. So it's going to be hotter because the sun is more concentrated. See, the distance between the arrows is smaller than it is down here. Here, there's a big, long distance between the arrows, whereas here, there's a short distance. So the sun is more concentrated in summer. Whereas in winter, when it's tilted away from the sun, now all of the solar rays are concentrated in the southern hemisphere, and they're less concentrated in the northern hemisphere. So it's colder because the sun is less concentrated. By the way, the reason why spring and fall are the way they are is because during the equinoxes, the sun or the Earth is basically upright, both during autumn and fall, during autumn and spring. And so there you have an equal distribution of the sun. Has the same concentration in the northern hemisphere as it does in the southern hemisphere. It's concentrated the same amount. And so that's what causes the seasons. What you end up with is concentration of sunlight due to the tilt.
Okay. So, but also to me, that's why I say partly, I believe, because when they've explained how summer and winter works on a flat Earth map, it also does work and make sense.
How does it work on a flat Earth?
So it moves closer in on the points, and it also links to the Bible as well, like fast and stuff. I can't exactly remember, to be fair. I could look it up quickly.
We'll give them a second. Everyone keep tapping that screen. We're almost to 750,000 likes, y'all. W squish them all in the chat, everyone. W squish them all.
I mean, importantly, what this diagram shows is that in the winter, in the South Pole, this is actually super relevant because I'd like an explanation for this on the flat Earth. In the winter, in the South Pole, you'll see that actually none of the sunlight, in the summer, in the northern hemisphere is summer in June. In the South Pole, you get no sunlight whatsoever. None of the sunlight will ever reach anywhere that's further south than this yellow line here. That's where Antarctica is. Similarly, in December, there will be a period of time when every single point further south than, here or so. It's not, the line isn't drawn. Every single point will receive sunlight all the time. So on a flat Earth, I would like you to explain why is it the case that during the winter solstice, during the June solstice, you get no sunlight at all, regardless of where you are at any time of the day in Antarctica. And in the December solstice, you get sunlight for 24 hours straight. How does that work on a flat Earth?
Robert, thank you for the $2. I appreciate it. Thank you so much on Cash App. I really appreciate it.
Okay, so with the firmament that the Bible does mention, am I correct? It does mention that?
Depends on your translation. In the King James Version it does, but in other translations it doesn't.
Okay. I was mentioning earlier, someone said like, oh, the Bible doesn't prove anything else. And I thought like, I've seen things about it proving the big flood, the Great Flood. There's like people have got a lot of theories of evidence of the flood happening.
I mean, we could talk about that, but I don't think that that's what Parker wants to talk about today, because today's not Bible Day. It's
because like where it mentions the firmament as well.
Well, that depends on your translation, right? If you look at the KJV, it does. If you look at other translations, it doesn't. Like any German translation doesn't mention the firmament at all, for example.
Also, we could just question the validity of the Bible in the first place. And if you can't establish the validity of the Bible, well, then there would be no validity in the claim that the earth is flat by virtue of the Bible being accurate.
Validity? Well, whether it's real.
Why is the Bible trustworthy? Yeah.
Well, like the sins, the deadly sins. And the commandments.
He's asking, why is what's described in the Bible? Why do you think it's true?
The sin and the commandments, like those things, because they just lead to trouble, don't they?
What?
Well, the Bible does talk about the commandments and sin, right? Or is it? Where does that come from?
Yeah, but what does that have to do with whether a flood happened?
The Quran also talks about sin. There are lots of religions that talk about their own prescriptions of what's right and wrong. Tell us why specifically you think that the Bible is correct and all these other religions are not.
I'm not saying all the other religions are not correct.
You have to in order to say that your beliefs are accurate, because they contradict yours, right? So they both cannot be true simultaneously.
Well, I'm not saying every single part of it is true. I'm saying that some parts of it, like the flood, the firmament that's mentioned, which you've said is not mentioned in all of it. So I'm saying
what evidence do you have for a global flood?
So, okay, I thought you said you didn't want to talk about that, but should we talk about that?
I mean, like specifically, I wouldn't want to go too much into it, but would you like to give me what you would reference?
So I'd
what type of
reference
evidence?
In a history timetable, there is evidence of bones from a certain period of time, and then for a long time nothing that they couldn't find. So almost as if there was nothing living because there was a flood. Does that make sense?
We have trees older than the flood, though.
Yeah, so the trees may have survived, but not all people, maybe.
How would trees... Wait a minute, I thought that in the Bible it says that nothing survived except the things on the boat.
Well, what trees survived?
I can look it up. I don't remember its name, but it's about 5,000 years old. The oldest tree, it is a Great Basin bristlecone pine. It is over 5,000 years old.
Okay. So how about the buildings that are obviously been flooded by a mud flood? Some sort of flooding that's underground. Well, the underground stuff.
Is this the Tartarian Empire?
Maybe.
Okay, so why do you think that a mud flood happened?
Because of the buildings and all the stuff underground.
What buildings and stuff
The
underground?
layers of the underneath the earth.
I don't know what you're talking about.
Okay, maybe I should go to bed.
I mean, yeah, but like, I mean, I'm confused. Why do you believe this? I actually really don't believe it's real.
I said part of me believes it. You know, I've said I've looked at some of
So
these
you don't
things.
actually believe it.
Part of me does.
I don't know. I don't even know what that means.
Why?
Part of me believes this. What does that mean?
Does that mean?
You can't believe it and not believe it simultaneously. That's not how it
Why
works.
not? Why not?
Because that's contradictory.
No, it's not. It's an unbiased point of view. It's not contradictory.
How is that? How is it being unbiased to assert both the negation and the assertion of the view to be true? What? That makes no sense. That's just contradiction.
These comments are cracking me up. Okay, I'm gonna let you go. Bye bye.
All right, only send a guest request if you disagree. We are just looking for some debates, y'all. Please only send a guest request if you think that the earth is flat, y'all. We're going to go into the next individual again. Oh, we got Jim is back. Jim is back.
Jim, how's it going?
No, not Jim. Jim Convict.
Yes, Parker. How are we doing?
The other Jim.
Yeah, that's right. How are we doing? You okay? I'm back anyway. I had to appeal anyway to get back onto lives because I was banned till the 3rd of January. So here we are.
You got your account back?
Yeah, I always had the account. It's just banned on lives, that's all.
No, is this account you're on banned on lives?
Yeah, that's right. Yeah, so I don't know
how are you on the live?
It.
Oh, they overturned it. Okay, you're back.
Yeah, they've overturned it. Yeah, I appealed.
Okay. All right.
Yeah.
So, like, where were we at? Were we at the end of the conversation, or were we at something specific?
Yeah, well, no, I was literally just getting into it, but obviously Dr. Blitz kept cutting me off and not allowing me to actually explain the theory.
Yeah, I don't know. Go for it, man.
He kept trapping me on because I mentioned Antarctic treaty.
He's muted right now. Just explain it.
Yeah, so I believe the flat Earth theory just because of like the obviously you got the sea level, you've obviously got the flight routes as well, and you've also got the Antarctic walls as well. That I feel like it's a little bit presumptuous that you have got the Antarctic Treaty, you have got the Operation Fishbowl, you have got Operation High Jump. And recently you've had also SpaceX, from that video footage, that looks like it's actually blowing into the firmament, if you ask me. So I want to know your thoughts on that.
Which one do you want to start with?
We can discuss SpaceX.
So if I pull up a video from SpaceX that is just a stream from the moment they launch until they get through to space, would that convince you?
So the most recent launch that they did into space, shall we say, the actual aircraft ended up blowing up.
Sometimes that happens. Why don't we look at aircraft or spacecraft that didn't?
Yeah, so if SpaceX, with all the technology they've got, is blowing up at that particular, it's not got very far, it's only got about 8 miles into the stratosphere.
So why don't we look at other flights where they
1960s?
Why don't we look at other flights where they go from the ground to space?
They can't get out of the firmament. It's impossible.
What if I show you a video of them being out of the firmament?
Well, they can't. It's impossible.
So you won't accept the video if he shows you?
Is any of the evidence coming from NASA?
No, it's coming from SpaceX.
Are they fake too?
They can't get out. Yeah, I'd love to see this video footage.
And are they fake too?
How can you prove that it's outside of the firmament, though?
Are they fake too?
I don't know. I've not seen it yet.
Well, hold on. If I show it to you, will you and it does show them in space, will you call it fake? Actually, I think that there's a launch that's live right now. Yeah, there's actually a launch that's, I guess, prepping right now.
So do you believe they've actually landed in the moon back in the 1950s?
Yeah, they did land on the moon, yeah.
Yeah, okay. That says it all.
Why is that a crazy thing to believe that we've landed on the moon?
Why have we never been back to the moon? Why have we only ever seen one
people, or just in general? Because with people we've been, or with people we haven't, but with rovers we have.
So why is there footage of like Neil Armstrong on the moon then?
Why is there footage of Neil Armstrong on the moon? Because Neil Armstrong was on the moon.
You just said that, yeah, we've been to the moon with a rover, but not with people.
No, we haven't been back since 1972 or 1973 with people.
Why?
Because there's no reason to.
You know why?
What's the reason
it's impossible. The moon's plasma.
Why is it impossible to?
The moon is
that's
plasma.
A positive claim. You should prove it.
Well, you only have to look in the sky to realise that it's translucent.
Can you define for me what plasma is?
I can't define it, no.
So you don't know what plasma is? How do you know it's plasma?
I can soon Google it.
Okay, so you don't actually know what plasma is, though. So why do you think it's plasma?
I know for a fact that it's not a physical object.
How do you know for a fact? Tell me about it.
Because of basic science of density.
Tell me. Okay, so what's the basic science? If it's basic science, it should be easy to explain, right?
It'd have to be lighter than the atmosphere.
Why?
Well, for example, like helium. That's how you get balloons in the sky. So
the moon isn't floating. The moon is orbiting.
No, the moon's
Should we try
plasma.
again? Well, that's a positive claim, so prove
The
it.
moon emits its own light as well.
Prove it.
So do you believe if the moon was a rock, it would not emit its own light?
Well, it would glow in the infrared.
Is it?
It would glow in the infrared, but yes, it is reflective, and most of the brightness that we see from the sun. What do you mean, what infrared?
No, it wouldn't.
Yeah, it would. Everything glows in infrared.
So the moon glows in the infrared?
Yes, everything glows in infrared.
I don't think it does. I think you're just making that up.
Okay, I guess you just don't believe that in basic thermodynamics, which is fine, I guess. But yeah, the moon's most of the light that we see from the moon is being reflected off the moon from the sun.
No, it's not, is it? Come on now. What about gravity?
How do you know?
Gravity is unproven. Let's just look at the
It's very proven.
forces.
Hold on, do you want me to show you how it's been proven? I can show you how it's been proven.
Gravity is unproven.
People seem to love when I just have tabs ready, so hold on, let me pull up a tab. Don't mind me, let me just find the right...
Not you showing your desktop. Your desktop number then.
Why don't you Google is gravity? Has gravity been proven?
Yeah, I'm going to show you. I'm going to show you an experiment that proves gravity is real. God, my internet's being really, really slow right now. Oh, I should close out of this, whatever this is.
It's not gravity. It's inertia.
Chat, is it easier to see on the bigger one or on the normal size
inertia.
one?
Gravity.
Sorry, my internet's being really, really slow. I'll just pull it up on my laptop. One sec. Let me pull it up. It's called the Pound-Repka experiment.
Go on to Google and type in, is gravity being proven?
It has been. I'm going to show you a paper. One sec. I'll just pull it up on my computer. Pound-Repka experiment.
Larger? Okay, I'll move to larger once he gets it.
Yeah.
The reason why
there's the Pound-Repka, and then there's the follow-up, which was done later.
The only thing holding the globe theory intact is gravity. Because otherwise,
that's not true.
If you didn't have gravity.
What's the name of the? Well, okay, I'll just pull up the Pound-Repka experiment.
Gravity is a bigger factor in that holds the globe.
Keep tapping that screen, everyone. Let's get to 750,000 likes. If you want to help get out to more people, everyone, keep sharing the live. We're almost to 1,000 shares, y'all. We're at 840 right now. Let's try to get to 1,000 real quick, everyone.
Let me find the paper. Give me a sec. But yeah, so suffice it to say, we do have evidence that gravity is real.
No,
and if my computer's internet would be faster... Oh, there we go. It's much faster now. Here we go. It's by Pound and Snyder. I'm sorry. This is a follow-up.
It's buoyancy and density.
Does light have buoyancy and density? So this is a paper by Pound and Snyder. It's from 1965, before we landed on the moon. It's called The Effect of Gravity on Gamma Radiation. Recall, blah, blah, blah. So they're talking about basically measuring the effect of gravity on light waves. And so there's a whole great...
This is when they made up the globe.
Light, thank you so much for the $20 on Cash App, and Marielle, thank you the $5 on Cash App as well.
It's a lovely
Thank you
paper.
so much.
I have a video actually. I actually have a video detailing this paper, explaining why it's such a spectacular paper. Because experimentalists are spectacularly good at their work. But I'm scrolling down to the bottom so I can show you what the conclusion is.
So do you believe the globe actually rotates on its axis at like 1,000 miles an hour?
Well, it rotates once a day. It rotates once a day.
Come on now. Wow, we can't seriously believe that.
So they do a systematic error analysis, which is great.
On our axes, and then we're also rotating around the sun.
Where is their conclusion? Should be somewhere here.
And then falling through fucking the Milky Way. It's just, you can't seriously believe that.
I mean,
surely.
it just sounds like you're just saying, oh well, it doesn't sound believable, so therefore it can't be.
Do you really believe that we're rotating?
Of course we are.
1,000 miles an hour.
Of course we are.
What do you mean? Of course we are.
I mean, we are.
Come on, you can't believe that.
There's a particular phrase that I'm looking for.
I believe that we are rotating at 1,000 miles an hour.
I'm sorry, it's true. Not only do I believe it, we know it's true.
My hairpiece falls off at like 60 miles an hour when I put my head out at winded out motorway.
Well, there's no wind in space, so you don't really have to worry about wind blowing your hairpiece off.
On a stationary flat Earth.
I don't see why that's relevant for your objection. Right. So here's, anyway, this is, I can't find the particular sentence, but this is a table that just shows their data. This one here, if the data matches the one, then that means that their experiment agrees with Einstein's relativity, which is a type of gravity. And you can just look at the data, look at all the error bars, it is consistent with one. The data collected is consistent with one. They're measuring the effect of gravity on light, which doesn't have any density, doesn't have any mass or anything. So I don't know what your I don't know what you're going to say about this. I mean, you're not going to read this paper.
We're not measuring
so
gravity in light.
Yeah. This paper did. In this experiment, they measured the effect of gravity on light.
Yeah, it's a lot of rubbish.
I mean, you can go read the paper and then tell me what's wrong with it.
So while
he never will. He never will.
He never will. Of course not. It's a great paper, though. Would recommend it to anybody who's interested. It's by Pound and Snyder. It's from 1965. It's like their experimental apparatus and their ability to control for systematic errors is spectacular.
I don't know what that article is. You're just scrolling through there.
Yeah, it's this paper, Effect of Gravity on Gamma Radiation.
Yeah, you bring an article up with a title and you feel like it proves.
Well, I've read the paper. So why don't we read the abstract? So the last sentence, is the result found was 0.999 plus or minus 0.0076 times the value of 4.905 times 10 to the minus 15th of 2gh over c squared predicted from the equivalence principle. The equivalence principle being Einstein's general relativity, which is a theory of gravity. So this is an experimental proof that is consistent with gravitational effects on light.
We're not talking about light, though.
Well, but if gravity happens to light, then I don't know why it wouldn't happen to everything else. Yeah. So this was tested on Earth. It's a test that shows gravity is real.
It's not a test on Earth. It's a test on land.
No. This was tested on the surface of the Earth. Like they did this experiment on land.
Right. Okay.
They did it at Jefferson National Laboratory. Like I can tell you where it is. There are other effects that we can look at if you're interested in them. for example, we can see that there is, what's it called? As predicted by Einstein's general theory of relativity, which is a theory of gravity, that we see that clocks move faster as you bring them to higher levels, as you like raise them up in a skyscraper, the clocks move faster. Here is the, actually, let me pull up the right paper. I have it somewhere.
Clocks move faster.
Yep, clocks tick, optical clocks and relativity. That's what this paper is called. Let me read the abstract. Observers in relative motion or at different gravitational potentials measure disparate clock rates. The predictions of relativity have previously been observed with atomic clocks at high velocities and with large changes in elevation. We observed time dilation from relative speeds of less than 10 meters per second by comparing two optical atomic clocks connected by a 75-meter length of optical fiber. We can also now detect time dilation due to a change in height near Earth's surface of less than 1 meter. This technique may be extended to the field of geodesy with applications in geophysics, blah, 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 blah. Point is they're measuring that a clock ticks faster at higher elevations, and that is a consequence of Einstein's general theory of relativity, which is a theory of gravity. There's so much proof out there. Also, there's something lovely called the Eitvos effect. The Eitvos effect shows that the Earth is round.
It's a theory. It hasn't been scientifically proven.
Wait, what do you think this paper is?
It's just a paper explaining.
What do you think this paper is?
Obviously, they're experiments, so they're.
What do you think this paper is? This is the original paper by Pound and Repka from 1960. These are experiments that prove the general theory of relativity.
Yeah, we're talking about gravity now.
The general theory of relativity is gravity.
Well, it's not, is it?
Yeah, it is.
No, it's not. Gravity doesn't exist. It's not.
The general theory of relativity is gravity. Should I just pull up the Wikipedia article for the general theory of relativity for you?
It's a theory.
That's fake.
It's a theory, and it's been proven with experiments that I just showed you.
It's a theory. It's not factual.
It is. I just showed you experiments that prove it's true.
It's a theory.
So, general relativity, also known as the general theory of relativity and Einstein's theory of gravity, is a geometric theory of gravitation. So the general theory of relativity is a theory of gravitation. And these experiments that I just showed you about, it's a theory that's been proven by experiments like this one, by experiments like this one, by experiments like this one, by experiments like this one. It's been proven with experiments.
I don't think so, because gravity would be factual and it's never been proven.
It has been. I just showed you experiments. It sounds like you're just going to keep saying that, but these are experiments that show you how it's been proven. Oops, I just closed out.
It hasn't been proven. I'll tell you what has been proven.
I mean, it has been proven. Here's a paper that proves it. They tell you how to do the experiment. They tell you what their data was. They tell you what the results was. They do the analysis. They do the systematic error analysis to make sure they're accounting for everything. This paper proves it. It proves gravity is real. Theory. It's not a theory. I mean, it's a model if you want to call it that. This is a fact. This is a real thing.
And buoyancy.
So where are your experiments that prove that density and buoyancy is all you need and you don't need gravity to explain why things fall? How does that explain the results of this paper here? The effect of gravity on gamma radiation. How does density and buoyancy explain this paper?
Well, I'm not talking about this paper. I'm talking about density.
Whatever theory of gravity that you come up with, it should be able to explain all the known results, including this paper.
No, because that's theory. That's just made up.
No. So your description, the reason why you think things fall is because of density and buoyancy. So explain how that affects gamma radiation.
Correct. Katrina, thank you for the $6.66. Thank you so much, Katrina.
How does that affect gamma radiation?
I don't know much about gamma radiation. That's why I want to talk about density and buoyancy.
Well, so something is affecting gamma radiation, and it's consistent with every model of gravity that we have, but it's not consistent with your model of density and buoyancy. So I think that your model we should probably just throw away, because your model can't explain this. My model can.
No, it can't. It's a
Sure
theory.
It,
It's not
it actually
proven.
does. See that level of agreement? 0.9999 plus or minus 0.0076. That is experimental agreement between the data that they collected and the general theory of relativity. Sorry?
Why is it they've got to blind you with science to make you believe the global theory?
Well, this isn't blinding. This is just a normal experimental paper. It's only 17 pages long. You could read it if you wanted to.
It is.
It's not. It's actually very readable. I actually, and in fact, more than that, I have a video explaining what happens in this paper, because this paper is so spectacularly well done.
Right, okay, can you move on from that article, please? Because it's not proving anything.
Because it's devastating to your argument.
Move on from the thing that disproves me, please, Blitz. Vic, thank you for the $1. I appreciate it.
Objection. Why are you objecting? Because it's devastating to my case.
Objection, you proved me wrong.
I cannot read that article. I'm having to squint. I'm having to squint to see my screen. Never mind read it.
You can pull it up yourself.
So you've read, obviously, like this article.
I've read this article. I actually made a video about it. It's quite short, only 17 pages.
Exactly. So you've read all these 17 pages, and you expect me to argue against you with this paper?
Well, so I'm going to tell you. Like, I can tell you what it says. I can summarize it for you if you want.
Go on then.
So they took a gamma ray source. Do you know what gamma rays are?
I don't know what gamma rays are now.
It's a type of light. It's like a type of light that comes from radioactive stuff. And in particular, I think they were using a radioactive source of cobalt. They basically shot that. Hold on, let me flip around my camera. They shot those gamma rays straight up. They shot the gamma rays straight up. So they had their gamma ray source down at the bottom. They shot the gamma rays straight up a 75-meter long, or a 75-foot tower. And they measured the change in frequency of the gamma rays as it was moving upwards. So they measured the frequency at the bottom, they measured the frequency at the top, and they found that the gamma ray slows down. It doesn't slow down literally, but its frequency slows down because gravity's tugging on it. And they found that it's perfectly consistent with the general theory of relativity. It slows down in exactly the right amount. So what they're measuring is basically the color of this light wave. It goes from blue to red as it goes from the ground floor to 75 feet up. Not obviously exactly blue and exactly red, but that's the idea. It loses energy. Its frequency decreases as it goes up.
Yeah, well, it will do with distance. That's all.
Yeah,
that's all that's proving, really. Distance.
Sorry, what are you saying? What are you saying causes it?
I was just saying, with distance, things slow down.
Why doesn't that happen horizontally, though?
It's like if you kick a football, eventually.
Why doesn't that happen horizontally? Why doesn't the same effect happen horizontally then? If it travels the same distance, it doesn't.
I'm using the analogy. If you kick a football up in the air, it comes straight back down. Gravity doesn't move side to side, does it?
Right. So gravity is what's causing this shift. The point is that of course not. That's why gravity affects the light ray as it goes up. Right. This is proof of gravity. That's the point. I'm glad we got there.
Yeah, gravity to me is up and down.
Yeah, I agree. So gravity goes up and it pulls down on the light wave, slows it down, decreases its frequency.
Is denser than its surrounding.
So light doesn't have mass.
I'm not talking about light. I'm talking about...
I am. That's what that experiment was. That's what I was summarizing for you.
Light works differently, though.
So light... That sounds like special pleading.
How can you measure light in terms of gravity? We live in a physical world. That's what that experiment does. Yeah? That's what the experiment does. Right. So let's just take it back to prove to me that the Earth is flat. So why are cars not floating off into the atmosphere? It's gravity. Because the car is denser.
Well, that's your hypothesis. That's your hypothesis, and I have a hypothesis called gravity. So, Jim, there are two competing models here. There's your buoyancy and density model, and there's my general theory of relativity. Now, both of our models.
Thank you.
Well, that's just the name of the thing. Sorry. We can call it a model if you like.
It's the name of the thing because it's a theory.
So Jim. So we have two competing models. Jim,
scientific proven forces.
Jim, we have two competing models here. We have general relativity.
Buoyancy.
Jim, please.
Theory. Come on, Don.
Jim, we have two competing models. We have two competing models. We have general relative.
One of them's a theory, which is what you're trying to explain. And
I was actually going to bring up Newton's universal law of gravitation.
That have been scientifically proven. Facts.
Jim, so we have general relativity is my model. We have buoyancy and density is your model. Now, both of our models, let's just grant that both our models can explain why cars stick to the ground. Can your model explain why gamma rays decrease in frequency as they go up?
I'm not talking about gamma rays, though, am I?
My model seems to be able to predict more things than yours does, which means my model's better.
Yeah, for measuring light.
For measuring everything. It can make more accurate predictions than your model can.
You're measuring light. I'm actually measuring
I'm talking about everything. Anything that your model can predict, my model can predict as well, but my model can predict things that yours can't.
Right, okay, so
my model's better. Yeah, that's how we judge scientific
it just
models.
means it's better at measuring light.
Well, but my model can do everything that your model can and
if
more.
I want to measure,
so my model's better.
I want to measure gravity, I'll use my eyes.
How do you measure gravity with your eyes?
It's dense. And
how do you measure density with your eyes?
Well, I know it's a fact, and I know yours is a theory.
It just sounds like you're in your feelings, Jim.
But you can't really see infrared, so that's what I mean.
I mean, you can with cameras.
Yeah, but I don't take all that as gospel.
What? So there's something that's called a what is it called? Parker, do you know the name of it? It's called like a gravity cylinder or like a density.
I have no clue.
Like a density cylinder, maybe?
Are you dismissing that buoyancy and density isn't actually force?
Buoyancy is a force, density is not.
Can you prove that density isn't a real force?
Yeah, it has units of kilograms per cubic meter rather than units of kilograms times meters per second squared, which is the units of force. They're different quantities.
Right, so how does that prove that density doesn't exist?
I never said density doesn't exist. I said it's not a force.
Well, it is a force.
No, it's not.
It is.
It doesn't have the units of a force, so it's not a force.
I don't understand what you're saying there.
I know you don't.
Of course it's a force.
It's not a force.
Of course it's a force.
Tell me, what is a force? What do you think a force is?
Google it. Is density a force?
Is that which causes acceleration. Vectorially causes acceleration. By the way, here's a cool video that we should watch. I'm gonna flip my camera around. Sorry, it's a short, so we'll have to play it out again. Ignore Stephen Colbert. Right, okay. So we just saw it on slow-mo, but let's watch it happen again. So the water's pouring out, right? Because it's denser than air or something, right?
Yes,
but
correct.
But then what happens? Wait for it. He's gonna drop the water bottle with holes at the bottom.
Yeah.
We're gonna get it on slow-mo. Why doesn't it pour out while it's falling?
Let me watch it again.
Why does it stop pouring out when it falls? See how it's not
So
pouring
the
out when it's falling?
prediction was exactly accurate.
I would just like to see your explanation for this. If Einstein is right, when you drop the bottle, the water will no longer feel gravity. So the water just stops spraying out. Oh, look,
yeah,
the prediction was correct.
The bottle's traveling faster than the water that's pouring out. So it creates a vacuum inside the bottle.
It creates a vacuum inside the bottle?
Yeah, because the bottle's falling faster than the water pouring out.
How does that create a vacuum inside the water?
Well, how am I going to explain that? It creates a vacuum.
So you're just saying it. You don't have any evidence, though, right? You don't actually have an explanation as to how it works.
It's pretty obvious to me.
It's pretty obvious. It's pretty obvious to me. It's a vacuum.
Hey, don't make fun of him just because he's a Britbonger, okay? We can look at we can look at a density column that's falling in free fall.
Then?
Sorry, no, that was just another. That was just. Here we go. Does buoyancy and density require a downward force, which we might call gravity? So let's test this. We're going to drop. This is a density tower, so it's separated things by density. As it's falling, we look at the accelerometer. See how it's mixing? I don't actually know if this video is showing anything. So now it's falling. I don't know what we're looking at. Why is it? Oh, fuck. It hit the ground.
Yeah, there you go. Density, just proven in that video. Thank you very much.
Wait a minute, but why was it moving around so much? Why did it mix? Why did it mix right before I hit the ground? Why is it mixing? If it's density, why is it mixing? Why is it mixing?
It is 1 o'clock in the morning where I am, to be fair.
There's another great demo of this too.
I don't know. Jim, what would you be willing to accept?
I don't know, probably nothing.
What about Bart?
Jim,
oh, here's a density tower on a 0G plane.
What are you using?
This is a flat Earth.
There's plenty of flat Earth. There's plenty of flat Earth TikTokers on here.
There's a flat Earth video.
Well, then tell them to come on the live. Who should I get on the live? Give me their ats, and we'll call them out.
Oh, God.
Density
give
tower
me the
on
ats of
0G.
I'm sure there's someone with a handle flat_Earth.
That's a 4-minute long video.
What'd you say?
True Earth.
It's very long.
Who?
I won't be able to find him without coming out of the chat.
Okay, so you don't know. Okay. All right. Well, okay. All right, everyone, tap the screen. Well, do you got anything else, Jim?
Yeah, it's flat. I've not seen anything from Dr. Blake.
I gave you so many pieces of data, so many pieces of evidence that show this.
Oh, you talked about...
Jim, have we talked about sunsets yet?
You talked about gamma rays.
Did we talk about
we
sunsets?
talked about gamma rays. Have we talked? Yeah, that's a good question. What about the Cavendish experiment? Have you heard of the Cavendish experiment?
I have heard of it, but I don't know too much about it.
So what's wrong with the Cavendish experiment?
I just told you I don't know too much about it.
Well, you should look into it. It was the very first proof of gravity in the 1700s, I think.
Yeah, but I find it very difficult to believe anything other than density and buoyancy because they are proven scientific forces. So until
there is no scientist that will call density a force. I'm sorry, there is no scientist on the planet, no physicist on the planet that will call density a force.
And gravity is an unproven force.
I gave you various demonstrations that it's true.
There's not, just because someone titles a white paper saying that it's true doesn't mean it's true.
I've read the paper and the analysis is spot on with the data that they collected.
Read it or not. I could write a white paper and just lie on it, make up a lot
So
of.
Are you saying that these people lied on the data collection? Because they did data analysis, and you can repeat the data analysis if you want.
Of course you can. Of course you can. They're only people.
So they just lied on the data analysis.
Yeah.
Right?
So then, Jim, what we want you to do is we want you to conduct the exact method that they conducted as they've laid it out. Right, and see if you end up with different results. Prove that they've done so incorrectly.
By the way, you get a Nobel Prize for this. You would win a Nobel Prize.
Yeah, prove that they lied. Win a Nobel Prize.
Well, unfortunately, I haven't got the technology to reach the firmament.
It was done in 1965, bro. You can do it.
Like I said, there's TikToks already on here on this platform.
There are no TikToks that debunk the pound.
Apparently not you. Apparently not you. So would you do this?
Me personally, no, but I could actually find you the evidence to do it. I won't be going out my way to prove it.
Oh, so then what? So you won't believe the evidence I give you, but you'll believe the evidence that some random TikToker gives you?
Yeah, of course, because I weigh both sides up.
Wait, you just automatically discounted the evidence I give you without weighing it at all.
Not really, no, because up until it's only the last couple of years I've actually believed in a flat Earth theory.
You had never heard of the Pound-Snyder experiment. You had never heard of that before in your life. So to say that you've weighed the evidence on that you're just lying to me. Don't do that. Don't lie.
I have weighed it up.
How could you have weighed it up without having read the paper?
Both sides of it. I've weighed both sides of the story up, and
you haven't, because you haven't looked at the paper.
More convincing. Just because I'm not looked at one of your theories.
You haven't considered all of the evidence. No, I'm sorry. You haven't considered all of the evidence. I'm just talking about experiments, not theories.
I think you're more convincing to this audience because you speak articulate.
I speak articulately because I am articulate. I don't know why that's relevant for the facts of the evidence that we have. We have loads of experimental evidence about gravity and the shape of the Earth. Loads of it. Bucket loads, even.
So how can you actually explain to me that the Earth spins at 1,000 miles an hour?
It doesn't.
Rotating around the sun?
Rotates once per day.
Yeah, at what speed?
Once per day.
At what speed? Is that speed?
Once per day. Rotations don't have speeds. They have angular velocity, which is once per day.
Rotations don't have speeds?
Yeah.
Right. Okay.
Angular velocity and translational velocity are different.
Again,
in fact, I actually gave a lecture on this last week. Sorry?
So if there's a ball, hypothetically, if there's a ball spinning, is that not spinning at a certain speed?
With spinning, it is spinning at a certain speed. One rotation per day.
So that's what I'm asking you. At what speed?
Yeah, one rotation per day. That's the speed.
That's a little bit vague to me.
it's 15 degrees per hour. Is that better?
I want it in miles per hour or kilometers per hour.
Rotation isn't described in terms of kilometers per hour or miles per hour. That's not how we describe rotation.
Come on now.
We just okay. So in your car, hold on. In your car, I don't know if you have a car.
All right.
I'm describing something to you. Does your car, when your car, it's telling you the rate at which the engine is spinning, does it give you an RPM or does it give you feet per second for the rate at which your engine is spinning?
What are you talking about?
We're talking about the rotation of something. Like in a car, have you ever driven a car before?
Yeah, I've got an X6, mate.
Yeah. So you know how there's something that tells you the RPM of your engine?
Right.
There's the dial. So that tells you how many rotations per minute your engine is spinning, or your shaft is spinning anyway, right? That's an RPM. Yeah. That's not in miles per hour. It's an RPM.
Yeah, the RPM, and there's also, obviously, if I'm putting my foot down on the gas, it'll tell me how many miles per hour I'm going in the car.
Yeah, it tells you how fast the car is moving forward, not how fast the car is rotating.
Why can't you give me?
Because the Earth isn't moving forward. It's spinning.
Well, surely if it's rotating on its axis, it's moving in one direction, isn't it?
No, it's not. That's the point of rotation, is that it's moving in both directions, so you can't associate a linear speed to it.
What?
It's revolutions per hour, revolutions per minute. That's how we measure speed, angular speed.
So you're saying
speed of rotation.
It's on its axis back and forth?
No, it just goes like this. The front part moves one way, the back part moves the other way. The top part doesn't move at all. It just spins. Like there is like, you don't associate rotation with translational velocity because it's not moving. It's just rotating.
Nah, I don't get that.
I know.
That's just...
All right, Jim, is there anything else you want to add or talk about, man?
No, it's all right. I'll get going.
All right. Peace out. All right, let's go on to the next person. Only send a guest request if you disagree. We are just looking for some debates. Tap that screen, everyone. Let's get to 750,000 likes. If you want to support me, Venmo, Cash App in the bio, as well as Gift Blitz, everyone. Gift Blitz. Yo, what's up? How old are you?
Hey, Blitz. How you doing?
Hey, Roy.
You had me around last week, remember?
Vaguely.
Nuclear tower?
Nuclear tower. Oh, yeah. Did you ever...
Yeah.
There was, I asked you to go make a measurement or something, right?
I don't remember you asking me to make a measurement, but I have better pictures. I have pictures that definitely include the ground now, and we don't have to speculate on a man-made object.
Sure. So for context, Roy lives in Bugaboo. Roy lives in Michigan, and he took a picture of nuclear tower and
across Lake Erie.
Ooh. Across Lake Erie. Oh, do you want to come up and say hi to people again? Yeah, I don't know, just because. She's back.
Who's she?
Anyway, my wife. So across Lake Erie, she can't hear you. So across Lake Erie was looking at nuclear towers, and apparently we shouldn't be able to see them. But you have better pictures now, so we can figure out if we should be actually able to see them, right?
Yeah. The point I want to bring up is you basically use the metabunkisjunk.org Earth Calculator website.
Walter Bislin's calculator, yeah.
To disprove that. And it comes up with roughly 300 foot of curvature is what you showed me. And
something like that. I don't remember what the number was.
I did the test again, and it had the same results, but now I've got pictures of land.
Okay, show us the base. Show us the
You're going to have to bring it up on your computer. I'm the guy that don't know how to use a smartphone, remember?
Is it on TikTok?
Yeah, Modern Day Disciple. Not on this profile, Modern Day Disciple.
Modern Day Disciple.
Yep.
Purdy, thank you so much for the 5 subs. I apprate the 5 subs.
All right, let's see this. Let's see this evidence. Modern Day Disciple. Wait, so did you take these pictures or?
I took them, yes, with an S24 or Samsung S23.
Modern Day Disciple MDD, that's you?
Yeah. First video. Let's look. Top left.
Is it pinned?
No, there's only 4 videos, dude. There's nothing to pin yet.
Is this on YouTube?
No, TikTok.
Sorry, I think I pulled up the wrong one because there's Modern Day Disciples, but that's not you. It's just singular.
Yes.
Does it have 316 at the end?
No. Roy Prevet.
Nuts. Modern Day Disciple. Let me put in Roy. Maybe we'll find it easier.
Again, everyone keep tapping that screen. Again, we like 4,000 people in here.
Oh, Roy Prevet, found it.
If we keep tapping, we can easily get to 750 in like the next
video.
10 minutes, y'all.
So here we go.
It's just a series of pictures.
Yep. Okay, here we go.
And you definitely see the land.
Wait, where do you definitely see the land?
You don't see the land that it's setting on?
No. I can see the tower.
What
I
do
see
you
a
call
horizon.
that?
I don't see the land.
Oh, okay.
I assume I mean, there's trees nearby, so I assumed if I see the land, I would see the trees, right?
There's not trees in that area. It's a nuclear facility.
There are trees on the shore. We looked at this last time.
And yeah, but I didn't go far enough to the right to bring in the bird watching community. So
wait, so what was this? What was the site called? Because we can pull this up on Google Maps.
Metabunk.org Earth Calculator.
No, sorry, not the Earth Calculator. The location of the power plant. What was it called?
Nuclear BESS in Oak Harbor, Ohio.
BESS. Davis Best Nuclear Power Plant, right?
Yeah.
So it's this guy. Just so everybody can see. This is what we're looking at here. So if we were seeing the ground, let's put on the layers.
Uh-huh.
Why aren't we seeing like all of these trees in front of it? Or these trees in front of it? Why aren't we seeing those? If we're seeing the ground. I mean, like, look at this picture, right?
It's 24 miles away, dude.
But you should be able to see something. Why aren't we seeing this building?
You can see something. You can see the building, and you
why aren't
can
we
see
seeing
the
these
trees.
houses on the shore?
Because it's a direct line of sight.
Wait, aren't you looking at it from northwest?
Okay,
From the northwest?
and you know what? Good job bringing
here,
up
right?
the houses. Go back to the first picture, Lunar Pier. Okay. Yeah, go back to the first pictures. There's some sort of commercial building there with a light shining towards the west.
Well, there's some sort of something, but who knows what it is. Yeah, so so you're looking at it directly. So this is your line of sight here. Is this way. So we should be able to see everything on this pier, right? We should be able to see everything on this pier. So why can't we see all of these houses? Why can't we see, wait a minute, is there a lighthouse nearby?
Yeah, but it's the other direction.
Wait, what's the lighthouse called?
I'm not sure of what that lighthouse is called.
Because, I mean, if you're looking at it from over here, all of these things in front of it should be visible. We should be able to see all of it, but we can't. We can't see anything in front of it. And
okay.
By the way, this doesn't look like the whole thing. This looks like maybe the top half.
Blitz, you're looking at 500-foot tower there. So
yeah,
how
so look, we're looking at like the
high-
top half, right?
In that picture there,
So in
yes.
this picture, yeah. So let's look at this picture again, or let's go to one of your other ones that are maybe more zoomed in or something. Okay, so in this picture, it looks like the middle is like just above the bottom here. So it looks like the middle would be like the middle of the tower is maybe like right here, because that's where it stops. That's where it starts to peak. That's where it starts to bend outwards again. Now look at this. Look how much space there is below the place where it starts to bend out. We are seeing. I can make this bigger. Come on.
So
in this picture, we're seeing this. This is
so
what
you're
we're seeing
making
in this picture.
refraction work for you.
I'm not using refraction at all. We're only seeing this part. I'm not using refraction at all. We're only seeing this much of the tower. Right. Let's go compare that.
The picture you're presenting,
doesn't
the trees look like they're half the size of the tower.
So here, we're seeing like this much of the tower. See how you can see it barely start to bend out again?
Okay.
That's what we're seeing here. We see it barely start to bend out again. And so in this picture, you're seeing less than half of it, right? I'm covering up more than half of it.
Yeah.
So you're definitely not seeing the bottom of the tower.
Yeah, he's
seeing less than half
curvature.
Yeah, so you're only able to see maybe the top third or something like that.
So what's
we
the
can go to
dark
Walter
line?
Bislin. What's the dark line? It's the horizon, bro. It's the horizon.
Okay.
Literally proved everything.
Bring up a clearer picture.
These are your pictures. They're not particular.
I know they are, and some of them are clearer than the others.
Okay. Oops.
Oh yeah, skip that one where you can clearly see the light in the building.
I'm trying. Which one do you want? This one or?
No, let's go back to the one that has the.
This one.
You can definitely see what appears to be a building with a light. Yes.
Yeah. There's. Oh, come on, go back. Sorry, it's just TikTok being dumb. Yeah. So again, you can see maybe the top third of the tower or so, and then there's something there. I don't know what it is. But we can look at how much of the tower we can see. You can see about the top third. Now, how far away did you say this was?
23 plus miles.
23 plus miles. All right, let's go to our curvature calculator.
Yeah, it's closer to 24, but I know what Weiner's.
Okay, let's put 24 miles. And you were observing from 10 feet up, you said? And the target.
12 feet.
12 feet up. The target is the nuclear BESS. Actually, you had it in a post. It was 493 feet, right? Something like that?
Yes.
Okay. So let's go to our curvature calculator, put in 493 feet, see how much we should be able to see. So the amount hidden is 260 feet. The amount visible is 232 feet. So you can see just about half of it, which kind of lines up with these pictures, right? You can see just about, you can actually, it looks like you can actually see less than half based off of this picture of what the thing looks like. So I don't know, man. It just looks like it's confirming what we're saying again. It looks like you're seeing roughly up to here, which is about half.
And what you're calling a horizon, I'm calling a compressed image of foliage.
Okay, so do you have any evidence of that?
I presented the evidence.
I mean, just from the picture alone, we can only see up to here on the tower. We can't see the bottom half from your picture. From your picture, we can see just where it starts to bend out.
Are you quite literally disputing your own images now?
Again, we only see the bottom half, or the top half. Again, we only see the top half. Again, we only see the top half. It starts to bend out right here. And as we see from this picture, it starts to bend out more than like a third of the way from the bottom. So like if we're looking at this right after it starts to bend out, that's less than halfway up, or more than halfway up, I guess.
All right. Well, I'm going to disagree with you. I think that's basically trees. I've got 5% left on my phone, so I'm about to die. But the previous caller, you brought up the experiment done in 1965, and you brought up Eratosthenes and his experiment 2,000 years ago.
Eratosthenes, yeah.
Yeah, Rodines, whatever. How come that they don't redo that exact experiment?
They have. So many times. In fact, I personally have. I've done it in collaboration with a flat earther, actually. On TikTok.
Did you do it in the same place?
We did it in South Africa, the UK, and the United States. We used 3 locations.
Oh, do you have that posted?
No, but I have the DMs.
Okay, well, 2,000-year-old experiment, and a lot of younger people.
It's been repeated a lot.
Let me finish. A lot of younger people don't realize that horses was the only way to travel back then. And, 400 plus miles, that was a 5-day journey for 2 people if they met in the middle. So no chance of that, of that data being corrupted in a 5-day ride, right? On dusty trails.
Greek students
and when they replicate the experiment, how many days later was it? If it was 10 days later, that's more than 1/10 of a season, and you're going to get varying results with different positions of the sun. Yes or no?
Greek students recalculate Earth's circumference, repeating experiment of ancient scientists.
Okay, well, I just... the comment section is always talking about older
modern replication of Eratosthenes' measurement of the circumference of the Earth.
And by the way, Michelson and Morley was a utter failure. And I've heard
they measured they got the null result, which means that there isn't an ether.
And Einstein's theory of relativity boiled down to the discovery of ether.
No, relativity came about because Michelson and Morley proved that ether doesn't exist.
They proved ether doesn't exist, but it does exist.
Well, Michelson and Morley's experiment disagrees.
Oh, so we don't have ether in our system.
The ether of the 19th century is false. It's not a real thing.
Wow, you just sell all kinds of used cars, don't you?
I don't sell any used cars.
What do you mean by that, Roy?
He's saying I'm lying.
No, I'm saying you're
quite literally are saying
things. You're switching things up.
So how is he switching things up?
Is ether not a common knowledge of
the ether of the 19th century is not real? No.
Oh wow! So my whole life's been a lie?
I guess.
If you base your whole life around that, yeah, I guess.
No, I'm just joking. So, all right, Blitz, I'll be back. I'm gonna let someone else get on here.
All right, for sure. See you then. All right, let's go to the next individual. Only send a guest request if you disagree. We are just looking for some debates. Only send a guest request if you think the Earth is flat. Everyone, tap that screen. We're almost to 750,000 likes, everyone. If everyone taps, we can easily get there, y'all. Yo, what's up? How old are you?
45.
For sure. Do you think the Earth is flat?
Yeah. How'd they communicate with the Apollo astronauts through the phone? The
radio.
How the world's rotating.
It doesn't rotate that quickly. It rotates once per day.
Does the moon rotate?
It rotates once every 28 days. Rotates very slowly.
Did they lose communication?
They did. Yeah.
How they broadcast live video.
Radio, the same way.
But we can't even do it right now.
We can.
Why don't they do it then?
From the moon?
Why don't they put a rover on the
moon? There are rovers on the moon.
Why aren't they broadcasting live? Which one?
Because they're doing science rather than trying to satiate flat earthers.
What? Why? You got
because
a bunch
science is more important than flat earthers?
Yeah, but you got a bunch of people that believe in the flat earth. So why
you guys make up like 1% of the population? The people who pay for these, I don't know. The people who pay for these rovers are interested in doing proper science rather than, catering to 1% of the United States population.
Why do they send pictures from Mars then?
For PR reasons, my guy. Because it's nice.
But why don't they do live video from the moon then?
So why are you why are you comparing live video to pictures? We have pictures from the moon, recent pictures from the moon.
Well,
that's very easy to do.
We have technology to do live video right now. Why are
we do, but it means that you have to bring more expensive, or you have to bring heavier equipment, and you have to bring heavier transmission lines to transmit at a faster rate.
So do it.
Oh, well, why not you pay for it? Why not you pay them to do it? Because they're not catering to you. I'm sorry, Joseph.
Money's fake, dude. It's just all printed. They have unlimited amount of money. They can do whatever they want, actually.
That's quite literally not how it works.
That's
if
fine,
you
I guess.
don't know anything about economics.
Yes, I do.
Okay,
money's not printed.
Yeah, you want to bet? So you understand? If you increase or inflate the amount of money, right, given the particular level of goods, right, if there's not a subsequent increase in like the aggregate supply, right, to make to also account for like the increase in aggregate demand, well, then you're going to have an increase in pricing.
And the thing about gravity or any of those things, can those be simulated in a virtual reality?
What?
Can gravity be simulated in a virtual reality, like a simulation?
Sure.
Okay, there you go. You could be in a
Are we in a simulation, Joseph?
You could be.
Prove it.
I just proved it. It can be done in
No, you didn't.
It could be done in a virtual reality simulation that we've already
prove that we are in an artificial.
We've already created it. Go look at a video game. Is there gravity?
No, I'm sorry. Prove that we are in a simulation.
The video game proves it. So if
a video game proves that a video game is a simulation. It doesn't prove that we're a simulation.
If we can do it, then someone else can do it, right?
Prove that someone else exists.
I can't prove it.
Well, then why do you believe it?
Just like
I appreciate the subscription. Thank you.
Can you prove there's gravity in a video game? Or there's no gravity?
Sure, you can prove that there's gravity in a video game.
Is there a sunset in a video game?
If it's programmed in, yeah.
There you go. So a sunset could be programmed in this simulation right here.
Sure can prove that we're in a simulation, though. That's on you, buddy.
I just proved it. We've created a simulation universe already. What are you talking about?
Wait a minute. We haven't simulated a universe.
Go watch Unreal Engine simulations.
We have not simulated a universe. But
Dude,
more than
Unreal
that,
Engine?
just because we've simulated it doesn't mean that we are a simulation. Just because we've simulated it doesn't mean that we are in a simulation.
We can simulate it, so someone far more advanced can simulate it.
Yeah, you have to prove that there is someone far more advanced.
How does something come from nothing?
I never said it did.
That's what the universe is.
Why do you think that?
No one's made that claim, Joseph.
Okay, where does the universe come from then?
I don't know.
See, you don't know. Just like
yeah,
God.
Okay.
If God's so powerful, could he make a rock so large that he cannot lift?
You would say no, God cannot do that because it would entail a contradiction.
Okay, then he can't do everything. So someone can't do everything.
Yeah, that's not the claim that the theist is making when they say that they're all powerful.
Joseph,
they're
you realize
that they can do anything in which is logically
possible. That's how God is fake.
Joseph, you realize Parker and I are both atheists, right?
I'm talking about just things in general. How they can be proven fake. I just proved God was fake right there. He can't do everything.
You quite literally did not prove God was fake. Right? I'm literally an atheist, and that was not an argument that disproves God.
If God should be able to make a rock so large he cannot lift, you should also be able to lift it.
That's quite literally not the definition of all-powerful that they're going off of.
He should be able to make a rock so large that he cannot lift, right? But he should be able to lift it
Why are you arguing? Why are you trying to prove that God doesn't exist to two atheists?
Because all these things, flat Earth or any science or anything, can all be done in a simulation.
Okay, so prove that we're in a simulation.
I just did. We've created it already.
That doesn't prove that we are in a simulation.
That means another.
Okay,
planet.
Joseph, hold on, Joseph. Let me ask. Okay, Joseph, hold on. We can make a simulation where humans can breathe underwater, right?
Yeah.
Can we breathe underwater?
Maybe.
Oh my God.
Depends on the planet that we're
So,
going to be.
so this is a wall.
This is a world that we're simulated in right now. It doesn't have those
Prove it.
attributes actually, but the simulators can change it anytime they want, though.
The burden's on you to prove that we're in a simulation.
I just proved it. We've created it already.
That doesn't prove that we are in a simulation. It proves that that simulations exist.
Is
Which
there
of course they do.
Is there an up and down in space?
No. Not canonically, anyway.
Is there time in space?
Sure.
If you saw no planets?
Sure. Yeah, there's time.
No, there isn't. You wouldn't know what time it
Okay,
is.
buddy.
How would you know what time it is?
Knowing
if you know planets?
knowing what time it is and time existing are different things.
But you wouldn't know what time you're in.
Joseph, are you did you take a lot of Advil today?
No.
Okay, just making sure.
There's a lot of questions that aren't ever answered. How come Buzz Aldrin said we didn't go to the moon?
He didn't.
Yeah, he did. He said it several times.
Are you talking about in the interview with the little girl where he says we haven't? When she asked why haven't we been back, he says we haven't been back.
How come we don't go back?
There is a mission that is planned to go back. In fact, we sent a probe last year.
And where's the footage of that probe? Live video.
Look up Artemis mission or look up Artemis 1 Orion mission. You'll find plenty of footage.
And it's live footage right now?
It was a year ago. It can't be live.
Why can't it? It's super close to us.
Because the mission's over.
I don't get.
They came back. The mission ended. They went there, did their flyby, and then came back.
Why can't you see any of the lunar landing stuff from a telescope?
Because it's very far away and small.
We can see other universes and galaxies. Other.
Cannot see other universes. Yeah, galaxies are big. Galaxies are very big.
We can't see them.
Galaxy big? That's small.
Hold on.
It's not that small actually. It's pretty big compared to where we're at.
It's about 5 meters across.
You can see it in the air actually with your own eye. What are you talking about?
Hold on. I have a clip that I'd love to play. Will this get us kicked off of TikTok?
Okay, I would yield the way not doing it then.
All right. How about audio only? Is audio only okay?
Yeah.
All right.
What is the audio?
It's just from a TV show from the 80s. It's dumb. I'll just say it. It's from a show called Father Ted. Basically, the main character is explaining to the very slow character that things can be small or things can be far away.
The moon isn't far
Small
away.
and far away. Moon is close, but lunar lander is small.
It's not that small. With the technology we have, we should be able to see it.
It's about 5 meters across, which is pretty small.
And we can see other galaxies
Yeah, those are
and other
very
planets.
big.
We can see other planets as
Yep,
well.
planets are big too.
See other planets, but we can't see the inside of a crater.
Yeah, planet's big, lunar lander small.
I'm talking about the crater itself.
So real. So can we get a so real in the chat, please?
Yeah, so
Anyway,
the moon.
all those answers could be simulated
Big.
in a simulation. That's why no
Okay.
one has the correct answer.
I have the correct answer.
No, you don't have the correct answer. The
I
fact
do.
that NASA's not doing any of these things is the correct answer, because they can't.
NASA's not doing what? They're doing plenty.
The moon landing was just propaganda to make it seem like we're more powerful than Russia. That's about it.
I mean, okay, let's say that that's true. Earth is still a sphere.
Maybe they went up to space, but it was broadcast from a studio probably.
Okay, maybe that's true. Well, actually, you know what? So you're right. They did fake the moon landing, but it was really expensive, so they had to film on site.
They didn't film on site. 'Cause they didn't go back.
Yeah. There was a last minute change, so that they had to go film on site.
So why do we need satellites or any of these things if we just broadcast, like you just said, from the moon and Earth back then?
Well, we use satellites for communication.
Why are we doing
it? And for GPS, for example.
Why don't we just use radio for?
We can use radio, but it'd be hard to communicate with the radio from Los Angeles to Australia because there's a planet in the way.
Why?
Because there's a planet in the way.
The planet was rotating. The moon was never even. The moon's not even there. So it's
Wait,
impossible. It's impossible.
What are you talking about?
The moon, the planets are always rotating, so there's no straight
The
line.
Earth rotates once per day.
It doesn't matter if it's rotating once per day. Once per day is another Earth thing. That's not even a time thing either. If there was no Earth, what would you rate a day as?
So we actually define a day as a certain number of seconds, and the number of seconds, or we define a second by the amount of oscillations of a hyperfine electronic transition state in a cesium atom. So it's there is 1 second in let me get the exact number for what the exact definition of a second is, because I can tell you what a second is. Right, the second is defined by taking the fixed numerical value of the cesium frequency, the unperturbed ground state hyperfine transition frequency of the cesium-133 atom to be 9,192,631,770 when expressed in the units of hertz, which is equal to 1/seconds. So there are 9,192,631,770 cycles exactly of the cesium-133 ground state hyperfine transition frequency in 1 second. That is how we define a second.
That's how you define a day too?
Yeah, and then we define a day to be a certain number of seconds.
Okay, so if you're on a different planet, is the day different?
Yeah, it'd be a different number of seconds.
Okay. Anyways, yeah, all that stuff can be done in a simulation as well.
Yeah, so now prove that we're in a simulation.
I just did. We've already created one.
That doesn't prove that we're in a simulation.
We can
Joseph, do you not Wait, hold on. So like, do you not understand why that's bad logic?
The Sims exist, therefore we have been created by God.
So if we can transfer consciousness, say in the future, and we transfer our consciousness into beings in a simulation, what do you think about that?
It'd be cool. I don't think it's possible, but it'd be cool.
But what if it becomes possible? Then
That'd be rad as hell, bro.
Then that means another advanced simulation could be what we're in right now.
It could be, but you'd have to prove that we are.
I just did. We've created one already.
Do you know what prove means?
We've made them already.
That doesn't mean that we are in a simulation.
Things don't add up. When you say NASA doesn't want to do this or NASA
Joseph, you say things don't add up. But like, have you done any math to check that?
Why don't they just launch people to the moon right now?
There is a project planned to do that. It's called It's called the Artemis mission. It's Artemis 3.
It's probably never going to happen. But how come they haven't done it? Like
They did it 6 times in the late 60s, early 70s.
They did it in a time where people didn't have that much information actually, and the information was transmitted to them.
So unfortunately, we live in a time where people like you have access to too much information, which is not true.
That means that's actually good. So we have too much information, so we should be going back to the moon.
Right. You have so much information that you can't tell what's true and what's not. That's the problem.
Like you can launch something there that just broadcasts live right now, current, and just solve.
Hey, do you want me to show you something that does that?
What's that? That's on the moon.
It's a live broadcast from space.
No, I'm talking about the moon.
Oh, okay. Do you think that space is real?
I'm not talking about a few miles above us. That's not even real space.
Oh, I mean, you wanted a live broadcast, right?
And then I have another question. Is gravity stronger on the surface of the Earth or lower as you get away from it?
It gets weaker the further away you go.
Okay, so why can't you just fly? Why do you need a rocket?
Because you have to get far away first.
So when you get to a lesser atmosphere, you need less energy, right? So why
It doesn't have anything to do with the atmosphere.
Why can't a jet airplane just fly to the moon then?
Because a jet airplane hasn't escaped Earth's gravity.
Why do they make rockets?
Because you have to get far enough away from Earth.
They're using all their fuel just to get off the ground.
Yeah, to get away from Earth.
When a jet can already get to, what, 70,000 miles above?
It can't get to 70,000 miles. What, are you high?
60,000. Some of those top secret
70,000 feet.
70,000 feet, whatever. And what's the atmosphere?
Yeah, the atmosphere there is pretty low. But gravitational strength at 70,000 feet is almost identical to the gravitational strength at the surface.
And how come when you shine a laser beam up to the atmosphere, it doesn't bend?
Why would it bend?
You said the Earth's curved and it's rotating, but didn't it bend?
Why would that make light bend?
Because you're stationed and you're pointing it up in the sky, and it should.
Yeah, so it'll just be a straight line, and it'll follow whatever angle you point it at. What?
That's like a flat Earth thing, though.
No, that's just how light moves.
But if it was the Earth's rotating at a fast speed and it's curved, it would look.
It's not rotating at a fast speed. It's rotating at 1 rotation per day.
Which is a lot. So if we're in...
No, wait, hold on. Have you ever seen... Okay, so I'm wearing a watch, right? You ever see a watch? Okay, so see that hour hand there, the short one?
Yep.
So you know how fast that's moving? Like the short one, it's not moving very fast, right? In fact, you can't even tell that it's moving at all.
If it was huge, it'd be moving super fast, actually.
Well, so imagine the Earth spinning half as fast as that.
If that was 24,000 miles in circumference, that would be fast.
It spins half as fast as the shorthand.
Okay, that's still fast. So if your watch...
It's quite slow.
If your watch was as big as the Earth, that would be fast, actually.
It's 1 rotation per... I don't know in what world 1 rotation per day is fast.
So how long does it take someone to get from one side of the Earth to the other?
Like in an airplane or a car or...
No, if they were to do it in one day, how fast would they need to get there? How fast?
Wait. If they were to do it in one day, it would take 1 day.
I mean, how fast would that person have to go?
If they wanted to go from one side of the Earth to the other?
Yeah.
If they wanted to do it in one day, they'd have to go... Well, I guess it depends on... Like, are they crossing like to their antipodal point, or are they just like going around 180 degrees?
They're trying to get to whatever the half the Earth is.
Like if they're trying to get to the point that you would have to dig through the Earth to get to the other side?
Whatever you're at and whatever's on the opposite side of you on Earth.
Yeah, so you'd have to move at about 1,000 miles an hour, 1,066 or so.
Okay, that's fast. Is it?
Yeah, I mean, it's fairly fast for covering land speed, sure.
Okay, yep, that's so. Anyways, so you answered none of the questions. Why isn't NASA doing any of these things?
I did answer your question. I guess you just didn't like the answer.
Okay, so when's this Artemis?
Artemis 1 launched in 2022. It was a probe mission before they send out anybody because they wanted to make sure that it's safe. Artemis 2, I think, is scheduled for 2025. Sure. So or maybe it might be Artemis 3 that's scheduled for 2025. I can double check. But Artemis 3 is the one where they're going to land on the moon. Artemis 2, they're going to do a flyby of the moon with people.
The only answer to all these things is we're in a simulation. Sorry, man.
I mean, you asked for an answer, I gave you an answer, and you just don't like it.
He just keeps asserting the same claim.
Can there be light in a simulation?
Yes, of course there can be. But you have to prove that we're in a simulation. I'm going to pull my hair out. Actually, Parker, this is as good a time as any for me to dip out because my wife just asked me to come eat dinner. So I'm going to go do that. We've been going for more than 4 hours now. But
yeah, it's been 4 hours and 40 minutes.
I mean, I know
everybody. Thanks for having me. And we'll have to do this again. I'll give you a few weeks to recover.
I'll message you about that. I'll message you on that, man.
Take care.
All right. What, you think you stumped him?
Yeah, I did.
You quite literally did not.
Why is he leaving? Why is he leaving?
He's been on for almost 5 hours.
What's your thoughts on a simulation then?
Joseph, he's been online for almost 5 hours. My thoughts, I think that a simulation, right, simply has no evidence, right? Therefore, I wouldn't really hold to that being true.
Why do you think there's evidence? We're actually doing it ourselves right now.
Of a simulation?
What do you think virtual reality is?
Because we have capacities to produce a particular simulation doesn't mean that specifically, right, we exist within a simulation. This would just be, again, restating the claim that it's possible, not that it's probable.
Well, it answers all the questions. It answers God. It answers the universe.
It doesn't answer it, right?
There's
Actually,
that's why.
a simulation just asks the question of where did this simulation come from? That's essentially what it is.
It comes from another simulation. It keeps on going on forever.
Yeah, so that's just infinite regress, right? So if you're saying that infinite regress is possible, then why wouldn't you apply that same notion to just like the base universe?
I do.
Okay, well then you wouldn't require a simulation.
I believe we're in something, because things don't add up. As we get more advanced, there's more questions.
But that's not giving evidence. You saying you believe something is not giving evidence.
Well, I mean, you can see with your own eye.
What do you mean?
And you can see how, just like the moon thing. How come we're not at the moon again? How come we can't go to
we already explained that it's earlier, right? That's going to relate to like costs. We don't really get anything out of it.
Have you watched the Indian landing of their lander? That was recently, like 5 months ago.
No, I haven't.
It looks like a 1980s video game. I suggest you go look at it. It's not none of the footage is plausible.
No, I've seen other types of footage. I don't really see an issue with that, but yeah. Is there anything else you want to talk about, or I'm probably gonna restart and go to a different topic.
No, I'm good, man.
All right, man. Appreciate you coming up.
Have a good night, man. Later.
All right, we're gonna get off and we're gonna go restart on a different topic, everyone. But I do appreciate everyone who did come through today, everyone. We will probably be on for another like 2 hours or so. 2 hours, yeah, probably. But yeah, if you want to join that topic, we're going to be doing the why is being gay immoral topic for the next like 2 hours, right? Because we don't have much time left anyway. So if you wanna come through, make sure to do so. Follow me if you have not already. I love everyone so much. Have a fantastic night, real quick, everyone. Love y'all. Be right back.